Good morning. Those that have logged in early, I appreciate this. It's Tim Peters, and we'll get started in about 10 minutes, but you should be hearing me now with audio. Hopefully the audio is good on your end. Any technical issues, just shoot me an email, tim.peters@usda.gov. Thanks.
Perfect. Okay.
Hey, Tim, can you hear me? This is Dan Chokas.
Dan, I hear you well. Thanks.
Good, glad to hear that. Say, do I need to be concerned that I don't see a share content button yet for sharing my screen?
Yeah, there should be. So at the top of your screen, is there a box with an arrow pointing up next to the leave button? Or it may be on a toolbar in the middle of the screen.
I'm not seeing that anywhere. Now I'm using the browser version of Teams, so maybe I should close that and open Teams
Well,
proper. Would that make a
and
difference?
that might. And Dan, I have your slides, so I can present them for you. That may be the easiest thing if that works for you.
Let's see here. Wait a minute. Oh, actually a toolbar button has just popped up on the screen. So I guess I'm okay. I see
Okay,
it now.
well,
Okay.
any issues, and I'll just progress your slides. But
All right.
yeah, you sound great, Dan. Thanks.
Okay, good. Thank you.
And for those just logging in, thank you for dialing in early. We've got about 5 minutes before we start, but we'll get rolling here shortly. Thanks. Morning, folks. Tim Peters here. We'll get going in just about a minute or two. Tim Royer, I see you on the call. FYI, your camera's on. Don't know if you intended that or not, but hello to you. Okay, Heather, I have 9 o'clock, so whenever you're ready to roll, go ahead and kick us off.
Good morning, everyone. Welcome, welcome, welcome. It's been a while since we've done a roundtable, and we're excited to have you all join us. Tim has prepared a jam-packed agenda for you with a lot of interesting subjects. So thanks, Tim, for organizing and coordinating. A few housekeeping notes. The meeting is being recorded. You should have seen that when you joined the meeting, but just so we say it. If you are attending this meeting and looking to get professional development hours credits for your PE license and have not already reached out to Tim, he's the person to talk to get that self-certification form. If you have already reached out to him, you're good to go, and he'll send it out to you after the meeting. A few housekeeping things this morning. Tim has the agenda up in front of you. We're going to try and stick to it as closely as we can, giving breaks where they're indicated or where they best fit in. They may be a little bit longer, a little bit shorter, depending on our presenters. We are planning on using the chat box for most of the conversations and asking questions today. So if you're not familiar with the MS Teams platform, if you look at the very top of your screen, over on the right, you'll see a red leave button with a telephone on it. Don't hit that. That'll get you out of the meeting. And then over about 5 or 6 buttons, there's a button that looks like a word bubble from a comic strip, and that is your chat box or your chat button. If you open that up, you will open up the chat history. In here, we will also be uploading documents that may pertain to the presentations. We'll also could be putting in links to outside information on the web. So the chat box is going to be our main means of communicating and sharing some of that information. The other thing too is when you do ask questions, we're going to primarily save questions for the end of the presentations, unless there's something that's pretty relevant and there's a decent break that we're not going to interrupt the presenter's train of thought. Then Tim or I might jump in and ask your question at that point. Some other common courtesy items, please make sure you're muted. If you're not and there's a lot of background noise, you may find that we mute you for you. The other thing too is some people are having or have bandwidth troubles. So we ask that you please keep yourself or keep your video off unless you're actually speaking. So at the very end of the presentations, if we open it up for speakers to ask verbal questions, you're welcome to turn that video on. We all love to see what everyone looks like, but just for bandwidth issues while people are presenting, please keep your video off. So that's what I had for housekeeping. Some general Pennsylvania NRCS engineering announcements that I did want to share with you. Just two real quick ones. If you weren't aware and you had worked with Bill Bowers, I did want to share that he passed away in November. I believe he was our state conservation engineer for about 24 years before Hosea, who was before Pete. And at the time when he retired, he was the longest acting state conservation engineer in the agency. So we lost a great one there. But with change and transition always comes. So since Pete retired, you know that there's been a series of actings. And I guess I should have introduced myself, shouldn't I? I'm Heather Smeltz. I am currently the acting state conservation engineer. And I'm glad to say that my term will be up in the beginning of January when we'll be transitioning to our next permanent state conservation engineer, Tim Peters. So Tim, we're glad to have you. And we're grateful that you are willing to step up and join those illustrious ranks. So with that, I think that's all I had for general announcements. Is there anything else that should be shared to the group at this time before we jump into our presentations?
I think that's good, Heather. There's nothing in the chat. Thank you.
Okay. All right. Well, then with that, Dan, are you on and loaded up and ready to go?
I am fully loaded and ready to go.
All right. Well, then with that, it is my pleasure to transition over to Dan Chokas for our first presentation. Dr. Chokas is an associate research professor at Penn State's Department of Ag and Bioengineering. He works to help Pennsylvania farms and related businesses develop bioenergy opportunities and improve energy efficiency. He's the Extension Program co-lead for Penn State's Renewable Energy Extension effort. He organizes Penn State's Bioenergy Short Course Series. He participates in Penn State's Wood Energy Team and Fuels for Schools groups, and he is an active participant in the USDA Sustainable Farm Energy Regional Project. He is also the coordinator of Penn State's graduate program in biorenewable systems and is co-chair of Penn State's Center for Biorenewables. His research interests include biomass densification processes, thermochemical conversion, and farm energy benchmarking. So with that, Dan, I'm going to turn it over to you for your presentation on perspectives on biochar for ag engineers.
Alrighty, terrific, Heather. Thanks very much. Can you see my screen now?
It's looking good.
Perfect. Okay. Then let's go ahead and get started. All right. So good morning, everyone. I'm really pleased to be able to speak to you today. It's kind of exciting, this illustrious group to be able to present to you. And I'm looking forward to providing this kind of biochar update and perspectives for agricultural engineers. And so for our time this morning, I do want to kind of start with a little bit of just kind of a why biochar, our motivation. You know, there's been a lot of interest in the topic of biochar lately, you know, both at the scientific and at the practical level. And kind of as an indicator, if you look at that table on the left, that lists the number of scientific publications on the topic of biochar from year to year. And as you can see, the number of scientific papers per year on biochar has just dramatically increased and continues to increase, as you can see. I mean, going from 147 papers per year at the turn of the millennium up to over 22,000 and counting this year. And it makes you wonder if maybe scientific journal articles should be converted into biochar as a possible feedstock, given the number of papers that are coming through. But you can see there's a lot of push from the scientific community on the topic of biochar. On the governmental side, there's been recent interest in biochar, and it's included legislative efforts to promote its use, things such as the so-called Trillion Trees Act, and also development of policies for its implementation, you know, like the NRCS code number 808, which is the Soil Carbon Amendment Protocol. I don't know how many of you are familiar with that, probably all of you. But anyway, with all of this activity, it's definitely worthwhile to consider if or how biochar should be part of our engineering efforts here in Pennsylvania. And so that's kind of the motivation behind all of that. And with that in mind, and to that end, today's presentation is going to cover first, what is biochar? Second, how is it used? Third, how is it produced? And lastly, what are the engineering implications? And throughout these 4 topics, I'm going to interject some examples for you of things that are happening in Pennsylvania relative to these topics. Some of them maybe you're familiar with, and others maybe it'll be new for you. But I really encourage you to stay engaged with the presentation by using that chat window. Add your comments, add your reactions, your thoughts for the benefits of all. You know, argue, type down when you think I'm crazy and wrong. That's great. I think that's really it really helps, I think, make the overall event more fun when I'm either presenting or viewing in one of these sessions. When the chat window is screaming along with a lot of side and relevant side conversations, I think that's when things are really moving, because we're not going to have that chance to sit around and drink coffee together and munch on snacks and have those side conversations then. And the chat window is really our best option. So I encourage you to do that as we're going along. Okay, so biochar, what is it? You know, there's a wide variety of opinions and views on it. You know, is it a panacea, that shining light in the distance that's going to make everything better, or is it a bright shining explosion that's just a boondoggle for us? And people have opinions throughout that along that spectrum as well. And I suspect that among you folks in the crowd today, there's probably a lot of different opinions represented, including the opinion of, I don't even know what it is to have my opinion, an opinion on it. And so is biochar an amazing opportunity, or is it a waste of time and money? I don't know, and time will tell. But first off, we have to ask, what is it? And definitions vary a lot, but at the fundamental level, biochar can be broadly defined as biomass that has been thermally treated to drive off volatile components of that biomass and leave behind a carbon-rich solid, something that's primarily elemental carbon. Okay, so with that in mind, you might be wondering to yourself, well, this sounds a lot like charcoal. Is biochar the same thing as charcoal? Well, in many ways, the answer is yes and no. You know, sometimes I like to joke with people that biochar is really just like charcoal, only more expensive. But the reality can actually be a little more complex than that. In part because of the terms biochar and charcoal are used in a variety of ways by different people. But we can generally say that while charcoal is manufactured with relatively few standards and a wide tolerance for those standards of performance, biochar tends to be manufactured to a much tighter tolerance with many more specifications. You know, in some ways, the difference between charcoal and biochar is kind of like the difference between a filet-o-fish sandwich and bluefin tuna for sushi. You know, they both are fundamentally the same thing, fish, but the subtle differences in their properties, the way that they're handled, and their end use, it results in a dramatic difference in their value. So are they the same? Yes. Are they different? Yes. Maybe it's not something to argue about. Okay, so with that in mind, I wanted to kind of pull back similarly on this topic, and at a broader level, we can think of biomass and biochar as existing on kind of a continuum of a variety of carbon-based products that can be produced. And the value of those products generally is proportional to the amount of effort that it takes to obtain and utilize them. So at the low end of the scale, we'd be talking about atmospheric CO2, which doesn't really require any processing on our part because it's already in the atmosphere. and it has a negative value in the eyes of much of society today. A small amount of processing in the form of crop management and or harvest gives us biomass, which has a little more value, and so on to charcoal, biochar, and then even higher value products such as biomaterials and maybe even diamonds, which are arguably the ultimate in processed carbon. But our concern, at least for this morning, is really down at that lower end of the scale when we're talking about the value that can be gained from turning biomass into biochar. So is biochar just a more expensive way to save charcoal? Perhaps yes. Is it worth it? Again, perhaps yes. Is it a good deal? Keep this in mind when you think about biochar pricing. Raw biomass probably costs about, very roughly, about $100 per dry ton. Could be more. Rarely is it less. The process of turning that biomass into biochar tends to reduce its mass down to, it's really typically more like a 2/3 reduction in the mass of that material. So therefore, biochar markets need to be willing to pay $200 to $300 per ton just to cover feedstock cost. That doesn't take into account the cost of manufacturing, the cost of testing, packaging, storage, transportation, retailing, all of those kinds of things. So when you think about the high price of biochar, you have to realize that there's actually a pretty high cost just to manufacture and create the stuff. So how is biochar used? There are a lot of potential uses that people talk about. Today, I'm just going to try to cover 4 pretty primary uses of biochar: soil amendment, water treatment and water quality, microbial community enhancement, and then also manufactured products and materials. So this is definitely not an exhaustive list, and I'm not going to go and exhaust all the subcategories within those 4 categories, but I think it's definitely a good starting point for us to think about where and how biochar has a potential to be used in the current modern economy. And while I'm saying this, I want to point out that a lot of these uses are becoming of interest and of value in the economy, not so much because the biochar itself is cheaper or performs better, but it has this added attribute of being renewable and of having the potential to be a carbon storage source, a way of storing carbon and potentially obtaining financial benefit for the storage of that carbon. There's a lot of push for a carbon market. It doesn't really exist beyond a voluntary market right now, which does exist, but there may be some mandated carbon markets that would likely dramatically up the price and the value of biochar. Okay, so soil amendment. So this is probably the primary application area for biochar in Pennsylvania and maybe even throughout the world. It's really the first and most commonly talked about use for biochar, and arguably the largest potential use for it as well. Key properties of biochar when it's being used as a soil amendment are things like the specific surface area, its cation exchange capacity, and its bulk density, which really play a strong part into not only its usability but its performance in this kind of application. Now there are of course others, and there are finer points related to that, but those are the real biggies when we're talking about using it as a soil amendment. And then, of course, its key effects are things such as the nutrient retention characteristics that we see. The soil is affected by water retention properties. Biochar tends to be pretty positive, pretty valuable in most of those ways. All right. Practically, How is it done? What kind of application guidelines do we have? Application rate can vary a lot, but some of the current recommendations are somewhere around 1% by volume as an application rate. It's incorporated into the top 7 to 10 centimeters of the soil profile, often using standard tillage equipment of one kind or another, such as a disc harrow. The value of that to the soil has tended, sort of the consensus from scientific studies right now is that the benefit to the soil is pretty limited for soils that are already of pretty good agronomic quality. Okay, and so because of that, a lot of the attention for soil amendment of biochar has shifted away from agronomic location spots where, let's face it, it's pretty straightforward and pretty well, I won't say straightforward, but it's fairly easy for farmers just to incorporate raw organic material into the soil as needed on an annual basis, and they have access to that organic material quite easily. And so purchasing more expensive biochar is not often that attractive to a farmer who's doing field crops. So instead, the attention shifts over to locations where you may not have the potential to be working the soil on an annual basis and incorporating organic material in, because biochar itself has much greater longevity in the soil, right? Biochar is actually, it lasts for thousands of years. That's when you think about archaeologists that are doing digs and finding ancient sites where people lived, they often are identifying and finding the fire pits because they're easy to see, because the char from those fire pits, it just lasts forever and ever and ever. And so its longevity is a real big plus, maybe not so much in farm fields, but in other applications instead. Okay, here's an example of a biochar demo that's going on it's actually just over the border in West Virginia. And this is part of a series of demonstration and test plots that are part of a USDA AFRI Sustainable Agricultural Systems project called Mass Bio, the Mid-Atlantic Sustainable Bioproducts Consortium. And that project's being led by West Virginia University, but Penn State has a reasonable role in that, as well as Virginia Tech, State University of New York, College of Environmental Science and Forestry, and a few other, some national labs as well. And so part of that, and that's a lot of the initial stages of these demo projects and test plots has been going on in this past year, establishing them, getting biochar into the soil in different areas so that we can take a look and see how they perform at scale. Another example from that, biochar trials with tree seedlings with an industry cooperator in the area. And of course, this is once again another possible spot where we have a higher value material, the growing media, where the cost of the biochar and the benefits of the biochar line up with the increased value of the performance in the nursery sector. Okay, next major use I wanted to go over is water treatment and water quality. Biochar functions similarly to activated charcoal in terms of its ability to absorb nutrients and contaminants. And so water quality structures, things like denitrifying bioreactors, retention basins, these kinds of water quality structures could potentially be really good spots for biochar and spots where the biochar can improve their performance. I don't know how many of you remember know Gary Gilmore. He was really Mr. Biochar forever here in Pennsylvania. And that photo shows him installing a biochar enhanced rain garden at the governor's mansion in Harrisburg a few years back. Using biochar for water quality, there are typically two main possible places that can happen. It can happen at the treatment plant, or in a distributed way in the landscape. That second one probably being the application of greater interest for those of us working in agricultural engineering. Here's an example of biochar being used for water quality purposes. This is at the Hanover High School, Hanover, Pennsylvania. Biochar was incorporated into this water, this runoff control structure at the side of their parking lot. And that was done in the fall of 2019. People involved in the United States Biochar Initiative, a gentleman by the name of Charles Hagberg, they were really instrumental in getting that moving. And there's a fair amount of monitoring going on in terms of measuring surface and subsurface flows and temperatures to get a sense for how is that biochar affecting the performance of that structure right there. Another example I wanted to point out in the area, and this is getting back to that Mass Bio Mid-Atlantic Sustainable Bioproducts project. They are partnering with some manufacturers of erosion control socks for construction sites and incorporating biochar into that mix so that we can take a look and see how that performs and see if that we can justify the cost of adding the biochar in terms of added increased performance of these devices. Right. Some anecdotal evidence is that they do perform better, but for how long and by how much, that still remains to be seen. Another example here is a retention basin in Reedsville, Pennsylvania. Here's where biochar was incorporated into the basin. And the idea is that the biochar will hopefully improve the infiltration characteristics of that basin, as well as enhance nutrient retention and enhance the establishment and maintenance of vegetation within that basin. And that once again just happened not too long ago, and we're looking forward to seeing how that performs over time. So there are quite a few examples of tests and demonstrations going on in terms of biochar being used in runoff control, water quality structures. We're not quite at the point where it's become a standard practice though, and there's a lot of question as to what's the right way to use it, how much, how should these things be designed, and is it really worth it? Is it really a recommended practice or not? Okay, the third topic I wanted to mention, microbial community enhancement. Now, if any of you have background in microbiology, this will be a little more interesting for you, and maybe you're already familiar with some of this, but it appears from scientific studies that biochar in solution helps to improve electron transfer in biochemical reactions. And microbes are all about these biochemical reactions that involve electron transfer as part of that reaction. And because biochar can improve the efficiency of those reactions, as a result, the microbes are more efficient in the way that they grow and produce whatever they produce. In addition to that, the biochar provides a medium for the attachment of those microbial communities. And so the combined effect there is improved performance. Now the application I wanted to mention here that's probably most directly related to a lot of our agricultural engineering work is anaerobic digesters. There are quite a few digesters on farm in Pennsylvania, and there may be potential to utilize biochar in these reactors to increase not only the amount of biogas that's being produced, but also the quality of the biogas that's being produced. And so that's kind of an interesting possibility. Now, an example of that, now that's not on farm, but it's actually at the a Milton wastewater treatment plant in the town of Milton on the Susquehanna River. They have 2 large digesters as part of that facility, and they have issues with the biogas quality such that they are not able to run their generators. They have these 2 massive power generators that they were hoping to generate a lot of power and help run the wastewater treatment plant on that power, but they haven't been able to run them because biochar quality has not, or excuse me, biogas quality has not been sufficient for them to use it. So we've been able to track down some U.S. Forest Service money to help pay for a little sort of practical full-scale test where we'll be adding some biochar every day to these anaerobic digesters and carefully measuring over time not only the amount but the quality characteristics of that biogas in terms of percent methane and sulfur levels in the biogas, and see if we can detect any changes in that performance over time. And that's probably going to get started in January. We've got our final approvals for that, so we're kind of excited to see what might happen there. Okay, next topic then is manufactured products and materials for biochar, a really interesting possibility for where it can be used. There are 2 main applications and for biochar in products and materials, and one would be replacing non-renewable carbon products of one kind or another, whether it's carbon black for tires for cars and trucks, or other types of applications where carbon of one kind or another is being utilized. Then the second is as a fill material to sequester carbon in that material. The picture here is from some research going on at Penn State where they're taking a look at 3D printer resin and adding biochar to that, which can not only change the properties of that 3D printer resin, but also sequester that carbon in that material. And so there's a lot of interest in that. We have been getting calls from companies that are interested in finding sources of biochar locally to use in their products as a way of improving the carbon footprint of that product and being able to gain a marketing advantage and access to markets and to be able to sell their product more effectively. So that is going on right now. Okay, biochar, how's it manufactured then? What kind of equipment is used right now in terms of equipment for and ways that biochar is being manufactured? There's not really a standard approach. There are a lot of different ways it can be done. Some of the key variable questions that need to be asked from an engineering point of view are, is this going to be a batch mode process, or is it going to be continuous operating mode? Second, what's the source of heat? Are we going to partially combust our feedstock to produce the heat to initiate the reaction, or is it going to be externally applied? Third, what's that process temperature and what's the duration? So the temperature that you heat it to and the length of time you keep it at that temperature has a big impact on the balance of your products as well as the quality and properties of that biochar. Scale of the facility, how large is it going to be? What are the co-products that are going to be produced? And that's important. You know, in general, the consensus is if biochar manufacture is going to be economical, then everything that comes out of that process needs to be used and sold. And so that includes not just the biochar, but any waste heat, which could be a significant amount, any off-gassing of either condensable gases or non-condensable gases. That all has to be considered, as well as, of course, the ecosystem benefits that are accrued as a result of the manufacturing process. All of that needs to be monetized if you're going to make a go of something like this. Example, this is sort of an education slash manufacturer example. Over the last 2 years, we've been having student design teams from multiple universities work together to design a biochar production system. And so last year they were looking at designing a large centralized regional manufacturing facility for biochar. And then this year they're taking a look at smaller scale distributed biochar production, something that would happen out in the field, out on in the forest landing, and seeing what they can come up with in terms of design of that system, not just the nuts and bolts of the conversion process, but also site development, the feedstock supply system, all of those kinds of things. Another example, we've had several logging companies that have studied feasibility of biochar and done some tests. Thus far, only one company I know of that has moved to production and sale, and so there's a picture of them. This is not an endorsement of them over or under any other company. It's just the first, I believe, that's in the market in the state of Pennsylvania. That's their display that was at the Timber Show this spring. So things are moving commercially in terms of biochar, and it is possible to obtain locally produced biochar for the first time in Pennsylvania. Okay, kind of bringing this around full circle, what are those engineering implications for us as engineers working in this area? The first thing is that I think we're going to be seeing more and more companies moving towards manufacture of biochar. And that means there's a need for engineering support of these efforts. And that includes process engineering, technical project development, and engineering economic analysis. And the engineering design community, commercial, the consulting engineering design community may not be familiar with that, and they may need some assistance from us to help understand some of these things, and also how these facilities can work well with the agricultural network and system and the way things work in the agricultural community, right? Second thing I think that we can think about in terms of being engineers is that utilizing that biochar, it requires engineering support. And the end users are going to need help with design of ecosystem applications in terms of what are the protocols, what kind of approvals are needed, right? How do you design these systems for the various uses? And then lastly, how can we take a look at engineering analysis of that carbon impact, which seems to be of growing interest and of growing likelihood that the value of that carbon impact could actually drive the economics of the entire process. And so those are places where we as engineers really have an opportunity to step in and hopefully make a positive impact. Okay, next steps and connections as we're wrapping up this session. Some of the possible places where you can be checking to get more information, people to talk to think about what to do next and figure out how to take advantage of this information or maybe work in this area. The U.S. Biochar Initiative is a great group there of people who have a great deal of understanding, knowledge, and enthusiasm for the topic. I'd mentioned Charles Hegberg as someone who's very active in that group, and he would be a good point of contact there. I don't know if any of you have worked with Ken Pentuck at US EPA office down in Philadelphia, but he is a unabashed biochar enthusiast who loves to talk to people about biochar and connect them with opportunities and possibilities. He'd also be a great person. Here at Penn State Extension, in addition to myself, another great person who's doing a lot of work with biochar is Ed Johnsonbaugh, and he's setting up for example, some stream buffer demonstrations involving biochar in southwestern Pennsylvania that are hopefully going to get launched early next year. And he's a great resource. And then that Mass Bio project, as I said, that the main lead for the overall project is West Virginia University, and the gentleman that coordinates all of their demonstration projects and things like that, his name is Sean Grashecki, and a good person to talk with. Other resources and contacts to think about. So at Penn State Extension, we developed a Biochar Opportunities Prospectus as part of a project where we worked in partnership with the Koppers Corporation as we looked at biochar possibilities. It did some market analysis and things like that. And so we have some reports from that could be very useful to you. We've also developed a biochar for water quality extension program. So we have some online articles. We wrote a prospectus and have a workshop curriculum developed that could be used in terms of working with local municipalities or people that need would like to understand a little bit more about where biochar can fit into local water quality issues. If you're interested in that topic of 3D printer resins and biochar, Professor Stephen Schmelly is the guy to talk to. And we had a student project where a student did a case study of that biochar enhanced infiltration basin in Reedsville and have written up some of the technical details regarding that, which can be a nice little read. And then lastly, biochar in riparian buffers. We do have an online article that introduces that topic as well, which could be good background reading for someone who wants to get started in understanding that topic. Okay. That's pretty much everything I wanted to say to you in terms of giving you an update. I feel like a year from now, who knows what else is going to be happening. Seems like the landscape is changing very quickly for biochar, but it's changing in such a way that the opportunities are growing and getting bigger. So I'm excited to see what's going to happen in the next 12 months. Maybe we'll have a chance to get together and compare notes at that point. So have a great holiday season, everyone. I hope to see you next year sometime. And I've really enjoyed speaking to you today on this topic. Thank you.
Dan, thank you very much. We have a couple of questions, if you don't mind.
I don't mind at all.
That'd be great. First question, where can farmers buy biochar in bulk? I know you mentioned the product that is available, but where can that be obtained?
Right. So that company, their name is Metzler Forest Products. And so you can just look them up on the internet and give them a call. They are the first company in Pennsylvania that's producing in Pennsylvania. Beyond that, you start to go to some companies out on the West Coast. There are a few out there that are producing and selling biochar, but I think it's a little tougher to get from them at this point because availability is limited.
Very good. Thank you. Next question. Is there a lifespan to the biochar, and is the material considered a contaminated material? Example, the biochar that is used for water treatment on a roadside.
Mm-hmm. Mm-hmm. That's a great question, and the answer is kind of we don't really know. We're kind of living in an era of unbridled optimism as to what biochar is and its overall impact. But some of those questions of how it should be handled after it has, for example, absorbed some contaminants and things like that is something that hasn't really been sorted out, I think, neither from a scientific point of view nor from a policy perspective.
Very good. Next question. What on-farm waste streams are used to create biochar?
Any biomass waste stream can be used. Now, does it make sense to do it? Some maybe or maybe not, depending on the specific situation. People have used animal manure to produce biochar. In some ways, you get a biochar as a result of that is kind of preloaded with nutrients, which may be good, may be bad. Then beyond that, probably we're looking at things like crop residues or residues from timber harvest. A lot of farms have a lot of woodlots, so there may be a significant amount of woody material, low-value woody material that could be repurposed for biochar as well.
Excellent. Next question. Is there potential for biochar to treat diluted waste streams such as milkhouse wastewater?
Yeah, I think there's a lot of potential for that, and even more dilute in terms of just overall runoff treatment. You know, denitrifying bioreactors. We've had a few students do some small projects here at Penn State, taking a look at biochar, mixing that in with the wood chips that are usually used as the medium in a denitrifying bioreactor, and measuring, so getting some measurable improvements in performance. So I can't see any reason why it would not also work on things like milking center wastewater. Yeah.
Okay, and then I have one question, more on a personal level actually, but I've been intrigued and watched several setups for kind of backyard setups where there are two series of two burn barrels, one smaller within the other one to generate biochar. I'm sure lower quality than the processing plant picture you showed would generate, but curious if you have any comments on that or experience. I just think it'd be kind of neat to try, and then something to add to my garden.
Yeah, I have not personally done that myself, but I know people who have, and I think it's definitely worth giving a try. The one thing you want to make sure is that you don't under process the biomass, and because in the early stages of heating, there's a tendency to produce polycyclic aromatic hydrocarbons, which are not the sort of thing that you want in your garden soil. And so you want to make sure that the heating is thorough, gets up to high enough temperatures, up above 400, 500 degrees C, so that you don't end up with any undesirable compounds that are left behind on your biochar.
Thanks, Dan. And that concludes our questions. I know I really appreciated hearing this, and I'm excited to see where biochar goes in the near future. So so with that, Heather, I think that's all the questions.
Sounds good. Thank you. And Dan, thanks again for presenting today. As you can tell by all the questions, there's definitely a lot of interest in the subject. One last real quick question for you that I had is, from the conservation perspective, do you have any suggestions for how we can support biochar or support our clients and landowners who are interested in biochar, realizing that there's many different applications from on the field to possibly the gasification side of waste to produce it that may be loaded?
Yeah, that's a tough question, and of course I think the first thing, of course, is to learn more about what's happening and connect with some of these local demos so you can see what's working and what's not, and use that as a starting point for the kind of recommendations that you can make to the farmers and landowners. I think that's what I would do. I think to just start to get some, that we're at a point where you can get some real hands-on experience with it, and there are enough people starting to do it that you can take advantage of their effort and learn from what's happening in some of these demos. And that would be my recommendation as a starting point.
Thanks, Dan. With that, we are going to transition over to Dmitry Resnick with TimberTech Engineering. With Dmitry, we also welcome Tim Royer, who's also on the teleconference, but Dmitry will be the main one presenting today. Dmitry graduated from Penn State University in 2007 with a bachelor's degree in architectural engineering with a structural emphasis. That same year, Dmitry joined the team of engineers at TimberTech Engineering and remains with the company today. Dmitry was the lead author of the Non-Diaphragm Post-Frame Building Design Guide, published by the National Frame Building Association, and he was also the lead author of Design Guide 12, Prescriptive Design Specifications for Non-Diaphragm Post-Frame Buildings, which is the topic of today's presentation. So with that, Dmitry, I am going to turn it over to you.
All right, well, thank you very much. Can you guys hear me, see me?
You're sounding good, and you're looking good too.
All right, just wanted to share my face a little bit so people can put face and a voice together. But so the goal of today's presentation is, of course, to talk about Design Guide 12, to provide an overview, and we have received something like 12 questions, 12, 13 questions from NRCS engineers. So we'll review those in detail. I do anticipate this presentation to take a form of discussion instead of a monologue, just because of the quantity of questions that we received. I assume probably 80 to 90% of today's time will be dedicated to answering those questions. So with that, let me say thanks to Tim Peters and Peter Vanderstappen. I hope I pronounced it correctly. But these two gentlemen we work with a lot in preparation of this guide. So I want to give special thanks to them, also NRCS, for letting us work and participate in today's discussion. So let me turn off my camera, and instead I'm going to share my screen. Okay. Tim, can you confirm that you can see, or Heather, that you can see my screen being shared?
Yep. You're
okay,
looking
perfect.
good there, Dimitri. Thank you.
Perfect. Okay. So Design Guide 12. That's, of course, the topic of this presentation. What is it? Design Guide 12 is a prescriptive design specifications for non-diaphragm post-frame buildings. The title could include the word comprehensive. I think it would be fitting to say it's the specifications are comprehensive in the sense that a designer is equipped with everything needed to specify a structural design of a non-diaphragm post-frame building all the way from the soils below the foundation to the purlins and sheathing above the structure. A little bit of history. This is a second publication or second document that we are producing for really the same purpose. The first one was the non-diaphragm design. Let me actually scroll it here. The non-diaphragm post-frame building design guide, which was produced, of course, with through NFBA, and that guide it really laid the foundation for this Design Guide 12. The difference between the two documents really is the first one is analytical. It provides specifications, instructions, provisions on how to analyze, how to design non-diaphragm post-frame buildings. It does give 2 examples, or maybe 4 examples, where this guide is really a continuation of that first document, and it provides 46 independent, comprehensive design examples. And as I said before, the design examples, they start all the way from the soils and end with the sheathing specification on the roof, including all of the connections. So let's do a quick overview of this guide. I did go through sections, and I highlighted some important information that I wanted to point out. So one thing to keep in mind is that this document was developed for specific building scenarios. In other words, it's not I should say it's not a salad. The individual designs cannot be mixed in. Each design has strict criteria assigned to it. It has geometrical limitations unique to each design, and so once the building designer identifies the building geometry, identifies load criteria, and identifies the design in this guide that fits the geometry and load criteria, the designer should really stay with that design. Separate designs should not be mixed together. So in this guide, buildings may be open, buildings may be partially open, may be enclosed or partially enclosed. and those references are defined in AC7. Diaphragm, even though the title says that design specifications are for a non-diaphragm post-frame building, it should be pointed out that this non-diaphragm reference is unique to a lateral load direction perpendicular to the ridge. In that direction, your frame, which consists of 2 sidewall columns, a single truss, 2 knee braces between the sidewall columns and a truss. So that frame exclusively is responsible for resisting lateral loads. But when we are talking about lateral loads in a direction parallel to the ridge line, we do not have any element that can help us except the roof diaphragm and the either shear walls or braced frames that are part of the sidewalls. And we'll show that graphically and talk about it in more detail a little later. Another thing to point out is the term in this guide, the term open sidewalls and sheathed sidewalls. I want to point your attention to the term sidewalls used within the term. The reason we're doing this is these terms are not equivalent or should not be confused with envelope classifications provided in AC7. So in envelope classifications in AAC7, you have open buildings, you have enclosed buildings, you have partially enclosed buildings and partially open buildings. The partially open buildings is the latest addition in AC7. In our terminology here, in this design guides terminology, we focus on whether your sidewalls are sheathed or if they remain open. That's the categories we're looking at. And again, we'll talk about it a little bit later once we look at the actual graphics and figures in this guide. I already said that design specifications in this guide are comprehensive. That's important. Okay, so how is this guide organized? Well, first, let me quickly go to a table of contents. So beyond the introduction of course talks about the background, defines the scope, defines the purpose. It points out important considerations which I already did, such as you cannot mix in different designs. It points to the fact that it is important for the designer to get familiar with the entire document. We got to understand that there's a lot of considerations in this design, and it's very difficult to organize it in a way that would not require the designer to be familiar with sections 2, section 3, design criteria, materials, building geometry. It really is not possible. So we really do encourage the users to get very familiar, especially if this guide is going to be used frequently. It's a good investment to get familiar with each section, to learn the limitations, the stipulations, to learn how to read design tables. But the way it's organized is the design guide lists the design criteria in section 2. Design criteria includes mainly loading stipulations. Section 3 lists the assumed materials, such as columns, headers, what's the grade, what's the species, what's the specific gravity, and so on. Section 4 addresses building geometry verbally, in writing. And section 5 is going to be very important. It is a graphical representation of the designs. It will show floor plans, it will show cross sections, it will show details of Y braces and connections, X braces, how to attach truss to the headers, how to attach truss to the columns. And section 5 will be used in conjunction with the design tables in section 7. That's something that the user will go back and forth between these two sections. So let's quickly go through the pages. I hope I'm zoomed in enough to for everybody to see what I'm showing on my screen here. So I already pointed some things out in the introduction. Let's scroll down to the, I call it schematic. I don't know if that's the right term. It's really a key, a plan that shows how the designs were organized. So this guide includes the design for 40-foot wide buildings, 50-foot wide buildings, 60-foot wide buildings, and each of those buildings is further broken into 12-foot tall ceiling heights. And that's important to know that we are measuring from floor or grade from floor to the ceiling line, not from the bottom of the columns, because the bottom of the elevation at the bottom of the columns, it's actually a variable, and it depends on whether the columns are embedded into the ground or if they are placed on top of a continuous concrete foundation. So the height is a reference to between the floor elevation and a ceiling elevation, or the eave of the building. So from here, the buildings are further separated into two additional categories, and that's what I mentioned earlier. Is the side are the sidewalls open or are they sheathed? And they're further broken into three categories. Are the columns pinned on top of the continuous concrete foundation? Are the columns fixed with a moment resisting bracket on top of the continuous concrete foundation, or are the columns embedded into the soil? So in total, there are really 52 designs, except that 6 of the 52 designs we were not able to provide a working design. The building was failing in such a way that it was not practical to specify columns that are not readily available. So this guide really includes 52 designs minus 6 that did not work out well. So we have 46 working designs here.
Dimitri. Question in the chat is, would you consider curtains on the sidewalls as open sidewalls or as sheathed sidewalls? Thought that was appropriate to ask before you move on.
Well, it's actually very interesting. From the standpoint of how the wind loads are being applied to the building, we could consider it as sheathed sidewalls. The only issue with classifying it strictly as sheathed is that anytime we use sheathed sidewall classification, we are actually considering wall girds as bracing elements for the columns. So in this design, anytime we say sheathed, we assume some form of rigid sheathing that will provide lateral bracing to the sidewall columns, so that sidewall columns do not buckle about the weak axis. And that's actually a good point to bring up. I would say you would have to use an open classification, and that's really the only way. Does that answer the question?
Yes, I believe so. Thanks, Dimitri.
Sure. Okay, so the design criteria, a couple just main things. I'm not going to go through every item. Of course, we have a lot of things to cover today, but the governing code, at least for structural design, is 2018 International Building Code. The loading is based on risk category 1 for agricultural buildings. The dead load, the roof dead load, is 5 pounds per square foot on top court, 5 psf on the bottom court, for the total load of 10 psf. The snow load criteria is based on 35 pounds per square foot ground snow load. And of course, it's reduced by snow risk factor and other factors per ASC 7. The roof snow load is 24 PSF. Roof live load is 20 PSF. The wind loads are based on basic or ultimate wind speed of 105, which is consistent with risk category 1. And that should cover most of the United States, of course. Exposure category, wind exposure category C. And building enclosure category, I will come back to this again just in case. So we have sheathed sidewalls and we have open sidewalls. In sheathed sidewalls, we had to consider several enclosure classifications, partially enclosed, but also enclosed and partially open classifications, depending, because sheathed sidewalls, you can have 2 sidewalls sheathed, you can have 2 sidewalls and 1 end wall sheathed, you can have 2 sidewalls and both end walls sheathed. And between those variations, you'll either have partially enclosed building, or partially open per ASC 7. And we had to consider the worst case to simplify this guide. The open sidewalls had to consider open envelope classification and also partially open. The materials section, it lists the materials used for columns, for roof purlins, for roof girders, for, I apologize if you hear the phone ringing, for truss materials. For example, for posts, and I want to point this out, for posts we used glulam columns. And when we say glulams, we mean true glulam columns. They cannot be replaced with any columns that have mechanical fasteners. Sometimes nail laminated columns, or actually frequently nail laminated columns, they also apply adhesives between laminations. And then once the adhesive is applied, they nail the laminations together. Those are not true glulam columns. It's important to note. So this guide is based on using true glulam columns that are designed and manufactured per ANSI A190.1 standard. I'm going to skip through some secondary framing. Of course, we specify the species, the grade for purlins, wall girts, and knee braces, roof girders, column-based brackets. Column-based brackets are probably the only component that is not specified by model name. And of course, that was done because it would not be appropriate to single out a single private company. I'm sure everybody's familiar with permacolumn products. I know Morton buildings, they have moment-resisting brackets as well, except I don't know if they're available for sale. There are some, it's not a heavy populated market. I don't think I personally only know of maybe 2 or 3 manufacturers, but there are manufacturers that make them. And so when we talk about columns that are pinned on top of the concrete wall, we're talking about columns that are bracketed, and those brackets should be designed, should have a design strength specified by the bracket manufacturer, and the design strength should include uplift strength and lateral shear strength of the bracket. Moment resisting brackets that attach columns to the concrete wall, and sometimes we refer to them here as fixed columns, are fixed on top of the continuous concrete wall foundation. So moment resistant brackets, they have the same, they will also have uplift capacities, shear capacities, and moment resistant capacities. And those capacities should be defined again by the bracket manufacturer. In addition to moment resisting strength, the bracket manufacturer must specify and should identify the rotational rigidity or rotational stiffness of the bracket. And because there are many manufacturers, we had to select a range of acceptable, the minimum and the maximum rotational stiffnesses of the bracket. And I have them highlighted here for 3-ply 2x6, 4-ply 2x6, 3-ply 2x8, and 4-ply 2x8 columns. I think it should be said that if rotational stiffnesses are outside of the specified ranges here, the internal shear and moment forces in the column will be different than what is assumed in this guide. Also, the loads on the concrete foundation could be different. Loads in the knee braces and connections could be different. So it is important to make sure that the rotational stiffness of the brackets are within the range that is specified here. Roof trusses, of course, are designed by mostly by the design manufacturer or a third party. The only thing that is important to point out about roof trusses is two things, actually. One is the top chord should be made of a material with specific gravity of 0.55. The reason that's important is because knee braces are being attached to the top chord of truss, and the connection design between the knee braces and the top chord of truss, they assume a wood with specific gravity of 0.55. If the truss designer uses wood with, say, 0.42 specific gravity, then the connection, the fastener quantities that are being specified in this guide, they would no longer be valid. And of course, at that point, the user may do additional calculations and put more fasteners than is being specified in the guide. But again, that type of work would be outside of the scope here. Additional important thing to note here is the location of a panel point. A panel point is where the webs of the truss are intersecting with top and bottom chords. And the panel point that we're noting here is the one between the web and the top chord. There should be a panel point right where the knee braces intersect the top chord, and we'll show it graphically a little later on. Structural screws are being specified, and the reason structural screws are being specified in many connections is, of course, because nails, if nails were specified, the quantity was just unreasonably high at some locations, especially in between the knee braces and the column, knee braces and the truss. Structural screws are being, in this design, were considered by many manufacturers, and we selected an average screw. In fact, we actually selected the values based on the weakest screw. So any structural screw that has about 1/4 inch nominal diameter, such as Simpson strong tie. We have many screws by Fasten Master, Timberlocks, Headlocks. They have many more. Those are acceptable. GRK screws are, of course, acceptable. So in the design tables, the screws will not be called out by the manufacturer. They will be called out by the quantity and length. Okay, so we're still in the materials. I believe this is still materials section. Let me start skipping over. I don't want to take too much time. Again, the list is quite extensive, and that's expected. Anytime we design a building, there are many variables, from how you calculate wind, how you calculate foundation design, how you model foundation, and it's that's just part of the game here. So I'm gonna start skipping through some of the materials here. I want to get to the questions that we received from NRCS engineers, just to make sure we have enough time to answer all of those. Building geometry. So this building geometry section is describes geometry in words. So things like building widths. This design includes 40, 50, 60. Building length. The minimum building length is 40 feet. We'll address it later in the question and answers session. Ceiling heights, we already talked. The bottom chord pitch, top chord pitch, truss spacing, roof overhang, and so on, just basic building geometry. Now, section number 5 is where it starts getting more interesting, more practical. I expect the users to spend most of the time in section 5 and in the section 7, which is the design tables. So here is where the design is being design specifications are being communicated, and they're being communicated, of course, graphically. Some things to note here is, because this guide includes 46 separate individual designs, it would not make sense to have specific drawings for all of them. It would just not be practical. So instead, the drawings here are presented as figures, something that you would see in textbooks. They're not drawn to scale, so they are figures, and all specifications that are common to all the designs, they are identified here in the drawings specifically. For example, some connections in these drawings, and we'll see some of them here shortly, they will specify the quantity of fasteners, for example, maybe a skirt board connection to the columns. But other specifications, say columns, they're just being called out as generically glulam columns, see design tables. And of course, the user would then reference section 7, which will identify the size and spacing required for each individual design. One common thing is, of course, trusses are spaced at 4 feet on center. The sidewall columns are spaced at either 4 feet on center or 8 feet on center. So the 8 feet was the desired spacing. It was our intent to make 8 foot on center spacing work wherever possible. But if this design was not working out using reasonable column sizes, then we had to default to 4 foot on center spacing. In a 4 foot column spacing, each truss has to line up with the columns. In fact, the columns are notched 1.5 inches to receive the truss. That is important, and again, we'll see it shortly and graphically. Whenever columns are spaced at 8 feet on center, in those cases, every other truss must line up with the column. The reason is, of course, is we're using the truss and the 2 columns, we're using them as moment frames. As soon as we attach knee braces between the columns and the truss, that becomes an equivalent of a moment frame, and we're using that to resist lateral loads. Okay, so figure 5.1 shows possible configurations for buildings with sheathed sidewalls. So what you'll see in common here is both of these figures, of course, have the sidewalls sheathed. They have girts, they have metal or plywood or OSB panels. In the sheathed sidewalls category, the buildings may also have end walls, either one or both sheathed, or they can have end walls entirely open. That is all of those configurations are still within the sheathed sidewall category. So as long as the sidewalls are sheathed, then any configuration, regardless of what happens with the end walls, those buildings will fall under the sheathed sidewall category. Figure 5.2 shows buildings that fall into the open sidewalls category. Again, here it can be seen that both in all of these configurations, the sidewalls are open, but one or both gable ends may be sheathed. Those are still within the open sidewalls category.
Dimitri.
Sure.
Now might be a good time to pause and answer a couple of the questions that have come up in the chat while you were talking. But the first one, for a heavy use area, it is common that one side may have sheathing and the other side is open. Would we use open sidewall design for both sides to be conservative, or can we use one side open and the other side sheathed? Wasn't sure if we can mix and match options from the design guide. Yeah.
This one is very tricky. And here was the issue. It kind of goes back to the scope of this guide. One of the challenges when we were selecting, and Tim, you will probably remember this, one of the challenges when we're deciding which building sizes and criteria to include was that as soon as you add one more variable, you double the quantity of sizes. For example, right now we have 48 designs. If we add a variable to the design where one sidewall is sheathed but second sidewall is open, now we have 96 separate designs. You add one more variable, now you have 192 or so designs, and it just multiplied very, very quickly. And so what it did, both, it kind of gave problems to of course, the budgets that we had in place, but also the practicality of this guide. If you have 100 some designs, it'd be more difficult to communicate. You now have more variables to consider. It more difficult to communicate the requirements. So at that point, the sidewall variables were limited that both are open or both are sheathed. Now, there is a discussion on this in the, I believe in the section 7. And from memory, we did provide some basic recommendations. So I would say something like this would be definitely outside of the scope of this guide. However, I think this guide provides enough guidance and specifications that a user may make, I don't want to say guesses, but educated decisions and still specify all member sizes and connections using this guide exclusively. But again, it's outside of the scope. It would be responsibility of the user to understand the nature of how the forces are being distributed, why we use knee braces, how we use knee braces, what each component does. I would say something like this should probably be done by a user who has extensive experience in structural design.
Very good. And echoing what you said, Dimitri, yes, we had a hard time keeping the number of designs down to a reasonable amount. So I definitely agree there and recall well. Next question, was the connection at the top of the post to the truss considered fixed or pinned?
Was the connection at the top of the post to the truss? So the connection between a post and a truss is in wood, is always pinned. It is very, very, very difficult to create a true moment resisting connection in a small area where the truss and the post overlaps. It could be done if truss heel was maybe 2 feet tall. It could be feasible to create a moment resisting connection. However, because of the use of knee braces, the overall assembly, when we look at the top of the post, we consider that a fixed connection when the knee braces are utilized. So the connection between the post and truss is pinned, but once you address the additional connection between the post and the knee brace and the top cord of truss, now we have a triangle that prevents the top of post from rotating about the truss, if that makes sense. So yes, so it's a yes and no question. No, the connection between the truss and post, which is that small overlap area, is not moment resisting, but the overall behavior of the post will be similar to a moment resisting connected member.
Very good. Thank you, Dimitri. And next question, and maybe this one isn't really for you, Dimitri, but should the truss plates have G185 galvanized coatings to meet the PA 367 construction spec for resistance to manure gases? And I did pull up the practice specification for that practice, and it does say that fasteners for roofs and covers shall be stainless steel and or galvanized in accordance with ASTM A153 and or A 653 class G185 galvanized, as Andy Hibbs here asks. So I don't know if that's an issue getting that galvanized coating on the trusses. Maybe Dimitri, you have a comment on that, but I would say that would meet the practice specification.
Yeah, I appreciate you answering the question. That my expertise is very, very narrow. I mean, I've been working on timber tech engineering for 14 years, and I do structural engineering exclusively. Anything outside of it, I'm very, very not well-rounded, let's say that. Do you have any other questions for me, Tim?
Yes. Yeah. And Andy, we can talk more offline on that, but I would say that based on what's in the practice spec, as I'm reading it, that G815 is a way to meet it. And I'm not sure if that's an issue or not from truss companies. Next question, though, Dimitri. Roof overhang is 2 feet in this manual or in this guide. So if we need a 6-foot cantilever truss to cover a feed pad, these designs couldn't be applied.
And again, it kind of goes back to the size of the guide or the quantities of the designs that could be included. So yeah, anything, the simple way to say it, anything that is outside of the specified geometry, anything that's outside of the specified materials, anything that's outside of the specified loading criteria is outside of the scope of the guide. I mean, that's a clean answer. But of course, if I was a building designer and I have fairly extensive structural engineering background, I could still use this guide for, if you have that variation where your truss is cantilevered, I could use 80% of this design guide to specify things that I am confident are not affected by that change. If I have to stay within prescriptive tables, I could maybe increase the size of fasteners, but again, that's outside of the scope of this guide. But engineers using this guide can have the flexibility to make some changes, as long as they have the experience and understanding of what those changes, how they affect the specifications and the results of this guide.
Thanks, Dimitri. That covers our questions so far. Thanks.
Okay, and it's interesting that we will probably touch on this a little bit as I mentioned before, for example, if we specify knee brace, it has to be southern yellow pine, and we may even say number 2. I don't remember. I think we say number 2, southern yellow pine. An engineer may look at number 2 or number 2 or better SPF and say, well, it actually has better, axial values, it has better bending strength values per NDS. So that means it could be an alternative. And it is true, except that it has the lower specific gravity. And the specific gravity is, of course, a function or a variable. It is the basis for designing the connections. So that's something that what I was trying to allude to, that changes can be made, but I would encourage changes to be made by engineers with extensive structural experience. If I know in the audience we have many disciplines here, and not everybody's a structural expert, of course. So, but if you have extensive structural experience, there are many changes that you can make as long as there's good understanding of what that component does, what will happen to the structure if you remove it, if you modify it, and so on. Okay, so if there are no more questions, I will keep on going. Yeah, we are at. Oh, we're running out of time quickly. Let me speed up here. I really want to get to those questions. Yeah, so graphically here in section 5, we're showing detailing of all structural, not just some, but all structural members and connections. Everything that is common we specify here directly. For example, we say fasten knee brace to the bottom cord of truss with 4, and we specify nails. That applies to all projects, all sizes, all designs. So we were able to specify it here directly. For things like connection between the bottom of knee brace and the post, we say fasten knee brace to column per design tables. And so the user would have to reference design tables to see what fasteners and how many are required here. Yeah, let me keep on scrolling. What you see here is the sidewall frame elevation. In this example, we're using Y braces at the top of the column. This was the default. We wanted to, this is where we started. We wanted to see if a building could be designed using Y braces. So this is the default position, the desirable position, because of course it allows the walls to remain open below. Any time we were not able to make it work, we introduced X braces. This will be one of the questions. So we introduced X braces. X braces really are K braces back to back. That's really what they are, and we'll talk about them a little bit in the Q&A session. We used columns 8 feet on center. Anytime that did not work, we had to reduce the columns to 4 foot on center, and this is what framing elevation looks like for columns at 4 feet on center with the X braces. Okay, we have connection specifications. We'll come back to this detail. It's also part of Q&A. This detail shows a section through the gable end section, gable end that has end wall columns, and then another gable end variation without end wall columns. We'll come back to that shortly. Here we're showing shallow post foundation. Again, we're specifying anything that could be specified specifically. We say it here, for example, locations of rebar through the post, but diameter, user would have to reference the tables. This is what the wall, continuous concrete wall foundation looks like when the columns are pinned. Again, pinned meaning no moment transfer between the column and the wall. This is what the wall looks like. Within this specification, again, I'm not going to go through because of lack of time, but in reality, there are 2 designs within this specification. Your foundation, your footing could be below grade at -2 elevation, floor being 0, or your footing could be raised up to the floor elevation. And depending on those variables, the size and spacing of rebar, or at least the spacing of rebar, will change, of course, because the moment arm or the height of the wall will be less if the footing is moved up. This is what the concrete wall looks like anytime the column is fixed. So now we have moments being transferred from the column into the foundation wall. And so this is the specification, the geometry, the rebar, everything is being specified here. Some detailing on control joints, detailing on rebar at corners, permanent truss bracing. So this is a roof layout plan with permanent truss bracing. This is what truss bracing looks like when you look at the truss profile. Again, I'm going to keep on skipping. This is what the shear, again, I'm calling it a shear wall. It really is a shear wall. And this is what the sidewall would look like if it's sheathed with plywood or OSB panels. I'm sorry, the top one is the roof. If it's sheathed with plywood or OSB panels, the bottom is the sidewall sheathed with plywood or OSB panels. Here's what it will look like if it's sheathed with metal, corrugated metal panels. Again, we have the specification called out here as how to attach each member, things that cannot be specified directly. We reference design tables. Section 6 is a structural design. This one is very, very, very important. It's also the least interesting, except for those engineers, of course, who, like me, really like structural design and spend a lot of time just reading a lot of detailed conceptual engineering type of material. But yeah, this one should be read by everybody because it not only talks about the conceptual side of how things were analyzed, but it also has additional stipulations that are important for the users to know. Okay, this graphic, again, I'm skipping. It shows how the point loads from the columns were distributed into the concrete wall. Here's on the left is a distribution of vertical loads. On the right is a distribution of horizontal loads and moments. On page 26, and we're going to spend some time on this one. This one is very important. So I'm going to briefly show it right now, but we're going to come back to it because this is part of this was one of the questions, and we're going to review it in detail. But this one is information on what information needs to be communicated to the truss designer. The truss is typically a separate component in most structures. It really, the main purpose is to design vertical loads. But in our application here, because it is being attached to the columns with an e-brace, the truss becomes part of the system. It is part of the lateral force resisting system, and therefore involuntarily the truss designer becomes part of the equation, and the loads, the point loads from the knee braces need to be correctly applied by the truss designer. So we'll come back to that shortly. And of course, this is in the section 5 and section 7 are the main sections. Section 7 is the design tables. It has some, again, we repeat a lot of stipulations, assuming that some users will skip and not read every section. So we sometimes repeat it, very, very important stipulations and requirements just in case. But this is what the design tables look like. So the design tables, of course, they include 40-foot, 50-foot, and 60-foot wide buildings. That's in a table title. They include 12-foot tall, 16-foot tall, and 20-foot tall buildings. They include open, sheathed sidewalls. They include pinned fixed and embedded sidewall columns. And the way the table is organized, you would read it from left to right. So vertically, it is complete, meaning we have 12-foot, 16-foot, and 20-foot buildings. There's nothing below that needs to be added. But horizontally, this table is very, very wide. It actually spans over 4 pages. And on the first page of table 7.1, which is the first table, it specifies column sizes. For example, if the building is 40-foot wide, 12-foot tall, if it's an open, the sidewalls are open. If the building is pinned on top of the concrete foundation, then the designer would use 4-ply 2x8 glulam columns. Glulam columns would have to satisfy the material specifications in the material section in terms of its bending strength, axial strength, shear strength, and so on. Column spacing for this example is 8 feet on center. Buckle and length coefficients, we're going to talk about this extensively. It's part of the Q&A, but it's shown here. In reality, the designer does not need to do anything about buckle and length coefficients. They are provided there as a to supplement, to kind of give the designer some background to make sure, you know, the correct values were used, because they will dictate whether the column passes or fails. They are very important. Foundation for this example is concrete wall A, which is graphically shown in section 5. We just quickly reviewed that. So yeah, let me keep on skipping over again. I want to get to a Q&A here. The second page is the same, table 7.1. We panned from left to right, and now we're still building 12. It's still open, still pinned. Now we're talking about end wall columns. We're talking about reactions at the bottom of end wall columns. We'll keep on going to the following page, which is still the same table. We keep on panning from left to right, and now we're for the same building, 12-foot tall, open, pinned. Now we're talking about knee brace design, the size of knee braces, how many fasteners you need to attach it to the post, how many fasteners are required to attach it to the truss. You see that the requirement is different, most likely because of the moisture, wet use factor. We're providing knee brace reactions, which would need to be communicated to the truss designer, and we'll talk about it shortly again. And this is the page 4 of the same table. Again, we're panning from left to right for the same 12-foot tall building. It's still open, still pinned. Now we're talking about header sizes. We also refer to them as girders in this guide. So in this case, it's 2-ply 2x12. The designer would need 10 20-penny ring shank nails to attach to the post. The attachment to the truss is specified in the next column. And the last thing I want to point out before we get to a Q&A is on the very last page of each table. So this is page 4 of table 7.1. After this table, we'll have table 7.2, and it will do the same thing, same 4 pages for 50-foot wide building. After those 4 pages, it will repeat again for the 60-foot wide building. But what's important to note here is the type of bracing in a sidewall frames. We will say either Y bracing or X bracing. And this is very important. They're not interchangeable. This is not this is not something that the designer can, it's not optional. If we say Y brace, we want the designer to use Y brace. Now, there is an exception, and again, that exception, even though it's outside of the scope of this guide, but it's if the building with Y braces work, it will certainly work with an X bracing. X bracing is clearly a lot stronger, a lot stiffer. So even though it's outside of the scope, of course, if the designer has sufficient engineering experience in structural design, that swap is possible. But if the building specifies X bracing, like in this case, Y bracing should absolutely not be used in place of X bracing. And we'll discuss it. This is part of Q&A discussion as well. So that's not so quick overview. Again, there's a lot of material to cover, so I try to skip as much as I can. But let's get to a Q&A, and we'll see a lot of these figures again while we cover Q&A. Okay.
And Dimitri, there were
Sure.
two questions in the chat too while you're going to the other generated questions from before. But if we're looking at the wall details, the wall sketches, is the maximum wall height above the floor 4 feet?
Yes.
Question mark.
Yes.
And
yes.
is that always the case?
That's again because of as soon as you add another variable, it multiplies the designs. So this design is going to be always 4 feet, and that's why when you look at this drawing, the 4 foot is explicitly stated, meaning it doesn't say see tables, or it doesn't give you any variation. It says 4 feet and there's nothing else. But when you look at top of footing elevation, it does give options. It says either -2 foot elevation, meaning 2 feet below floor, or 0 elevation, meaning flush with the floor system. So again, that it's important to remember that if graphic specifies information explicitly, then that's not a variable. I mean, there is no options for it. But if it gives variations, such as, like I said, top of footing elevation, or you can look at how the rebar is specified here in the same example. If your footing is 2 feet below grade, the designer would use number 5 vertical rebar, 10 inches in center, and that would be centered in the wall. If the footer is moved up by 2 feet and is flush with grade, meaning your concrete wall is only 4 feet now total, including anything below grade, because there's nothing below grade anymore, then the vertical rebar could be increased to number 5 at 18 inches in center. But yeah, the 4 foot dimension is not a variable. It's always there. And let me Tim mention one of the things. So in theory, when it comes to looking at the concrete wall itself, if you reduce the 4 foot to say 2 feet, of course it could be argued that the wall is now shorter, so therefore the demand on the wall is lesser. The reason it wasn't options like these weren't given is there was a concern that if a lesser wall height was specified, the user may interpret it that the column now may get longer by the same amount, meaning that the building height did not decrease, but the wall height decreased. And now the column, instead of say being 12 feet, it became 14 feet. And now that changes the design. It was very difficult to bring clarity, even though this could be done, but to bring clarity that if you reduce the 4 foot to say 2 feet, you have to shift the entire building down. You cannot just stretch the column, if that makes sense. Again, this is outside of the scope of this guide. It can be done, but it's outside of the scope of this guide.
Very good. And I think, let me rephrase the question a little bit. So if you go with the -2 for the footer elevations, what would be the wall stem length there? What would be the stem height? Would it be 4 feet or 6 feet?
Yeah. So so the 4 foot is not a variable. It's always there. So the top of wall elevation will always be at 4 feet above the floor elevation. The only variable is the footer elevation. So the footer, so the way we looked at it, instead of the floor moving up and down, we said the floor is actually constant, top of wall is constant. We're gonna make the top of footer a variable. So the footer either moves up or moves down. Is that a better way to explain it?
Yes, I believe so. Thank you. And then another question, the BCSI permanent restraint bracing for the bottom truss cords show overlapping by 1 truss, and I'm assuming you're probably familiar with the BCSI, or using a scab block over the splice. And looking at detail 4.17 in the design guide. Is this consistent with the BCSI requirements?
Okay. Yeah, so we do defer to BCSI because BCSI is it really is a prescriptive way of bracing the trusses. Now, just to confirm, it's not the BCSI, the bracing BCSI was not meant to resist wind loads, for example, out of plane wind loads on the gable end, for example, and so on. It's there to brace the trusses. So we do defer to it. This is a standard connection that we use here to overlap a 4-foot truss. That would, of course, require significantly more lateral braces to be used because of that. So this is a brace that we use. If BCSI shows something more stringent than this, then I would recommend using BCSI. With that being said, the main purpose of restraining the bottom cord is to resist buckling when the truss is being loaded in uplift. So when it's being loaded in uplift, the bottom cord is now a compression member, and let's say it has 2,000 pounds of compression, 5,000 pounds. But when you look at the actual buckling forces, they're very small. They're often estimated as 2% of the total axial load, and that's a conservative estimate. So I'm not authority on this. If BCSI shows something different, I would defer to BCSI. On a personal note, I would be okay with this detail, except for the very big buildings. Maybe then I would be a little more concerned about this.
And that's all the questions I have right now. So if you want to go back to the other questions. Thanks, Dimitri.
Sure. Okay. So let's, I'm not going to show the questions on the screen. I'm going to keep this design guide 12 on the screen that I'm sharing, but I have questions to my side here. So question number 1, and it consists of 3 separate questions, is concerning the information that needs to be communicated to a truss designer. Okay, and so our response would be based on page 26 in the design guide. So the question is, what information from the design guide needs to be given to the truss designer? What values from truss design should we be checking to confirm it meets design guide 12 requirements? What knee brace loads should be provided? And there's a recommendation, maybe show sample truss design and highlight items we should be reviewing. So let's spend a little bit of time here because, again, it is very important. We, when we were providing recommendations, we spent a lot of time on this topic. In fact, we actually changed the way we do it in-house for our site-specific projects because there has to be simplicity. If there's no simplicity, you may be very precise, but the room for error now just skyrockets. So we wanted to provide recommendations that are safe, conservative, but also very simple to avoid potential errors. So what information needs to be communicated? Again, as I mentioned before, truss is now very, very, very important. It's part of the lateral force resisting system. This is not typical for a truss in most post-frame building applications. So because of this, it really complicates everybody's work, the building designer and also the truss designer. So it is important to communicate several things. And we, on page 26, the design guide lists all the things that should be communicated. I'm going to go through the list. Some things I'm going to go through quickly, and some I will pause and talk about a little more. So some basic things, of course, as with any building: the wind speed, exposure category, risk category, building mid-height, envelope, enclosure classification. Now this one is based on AC7. So you know, the truss designer that will not should not care whether our building has sidewalls enclosed or open based on how this design guide is organized. What the truss designer should know is, per ASCE 7, is this considered partially enclosed, enclosed, partially open, open, and that needs to be communicated. Of course, dead and snow load, 5 psf, top chord, 5 psf, bottom chord, truss spacing. In this guide, it's 4 feet on center, always. Truss geometry, span, roof pitch, location of the knee brace intersection with the top chord, and we really encourage to actually show it graphically. Something that looks maybe very similar to figure 6.5 should be a good reference point, where figure 6.5 does show the loads, which we'll discuss shortly, but it also shows the location of the loads, of the point loads, knee brace forces. The truss designer needs to know that those point loads should be applied. Loads should be applied at 3 foot horizontal dimension away from the outside of the header or roof girder. The truss designer needs to know that a panel point is required. Now, we talked about this with truss designers that will work here, and they do say sometimes the truss works without panel points. Now, because we had to make assumptions and had to model each of the 46 designs, we had to make assumption of what the truss configuration looked like, and to make sure that we're not applying bending to the top chord of truss. In all of our assumptions, we placed a web and made it intersect with the top chord right where the knee brace intersects. So it should be a stipulation, should be a requirement. Even if truss designer says it can work without it, I would encourage to insist that they put a panel point. That without a panel point, the lateral stiffness of the frame may be significantly less than what we anticipated in our design. And of course, that changes the knee brace forces, that changes the moment reactions at the bottom of the column, and many other factors. So the truss designer should know that top chord, regardless of whether his or her analysis requires it or not, the top chord should have a wood with specific gravity of 0.55. Now, if it was already delivered, they somehow missed it. Of course, the building designer has the flexibility to put more fasteners. Again, it's outside of the scope, but it should be within the competence of the building designer to put more screws based really by comparing how that screw performs in southern yellow pine wood with 0.55 specific gravity, compared to how it performs in 0.4 in spruce pine fir SPF wood with 0.42 specific gravity, and just look at those ratios and increase the quantity of screws based on the ratio. So it can easily be done, but it definitely be easier for the truss designer to specify the correct wood species in the first place. Okay, the next one is, of course, we need to communicate the loads to the truss designer. And part of communicating the loads is, of course, communicating the magnitude, but also communicating the direction. And our recommendations would be to communicate it graphically exactly as we have it here. It would avoid many, just so the truss designer not to give much room for incorrect interpretation. So these would be wind loads on the truss from a knee brace. And we have two wind cases, wind load case 1, wind load case 2. And while I am showing this, I do have an example of a truss that I want to share with you, and it should be right here. Okay, so this was prepared for us exclusively for this presentation by Rigid Ply Rafters, and it should match for the most part the design criteria for that very first example in the design tables, which is 12-foot tall ceilings, columns on top of concrete wall, columns are pinned, And so what a designer should look for is, of course, just basic geometry. That is very standard for any building, roof pitch, basic loading, top chord load, live load, top chord, dead load, bottom chord, dead load, code references, IBCs, the correct references, and so on. But the focus is, of course, on two things here. One, the truss design should be first designed, or should be designed with and without knee brace forces. That is important. Even if your columns are spaced at 4 foot on center, which means there is no intermediate truss that would not have knee braces, even then it is important to make sure that truss can support the loads without knee braces. The reason for this is, even though we anticipate that in most cases knee braces will provide a worst case scenario, worst effect on the truss, it is possible that in some cases they may actually effectively shorten the span and may provide favorable effect to the truss, meaning less conservative. So it's important that truss can support just basic uniform dead snow loads without applying point loads to the truss. And then the same truss should be designed to support the same dead and snow loads, in addition to the concentrated point loads from the knee brace. And what we have here is exactly that. The first page that that Rigidply sent us was, and again, we're not endorsing Rigidply, just one of the companies we work with a lot, but there are many truss manufacturers. So what we show here on the first page, this report does not have knee brace forces. It's really based on your typical uniform loads, as you would expect. And then the next page is the same truss, and here they did apply point loads. And in this report, let me see if I can highlight it, they show or describe the point loads that they applied right here at the bottom. And they say, so they applied 2,550 pounds up and 2,550 pounds to the left at location 37, which is your right location. So it'll be right here. And so we can go back to our example and to see if they did it right. So this is wind load case 1. They applied 2,550 up and 2,550 to the left. That seems correct to me. And they also applied 1,750 down and 1,750 left at location 3 from the top. So that's location 3 from the left. And yeah, down and left seems right to me. So those are the types of things that in this case it's very clear. I appreciate that they kind of showed here. Now the loads are presented without the loads in this guide have not been reduced by the 0.6 multiplier to reduce them to the allowable stress level. So they are as they would come from the ESC 7, before the reductions, which means if they applied it, if the truss designer applies it directly, I personally would not mind if they reduce it or don't reduce it. We know if they don't reduce it, that's a conservative position. But these are the type of things I would look for, when I'm looking at the truss design. And of course, there should be a third design where they applied wind load case B, which is this one, which would be has some different loads on the truss. Yeah, so they describe it right here at the bottom. Another thing to communicate to a truss designer is to simplify their role is their first design, which does not have point loads. It would be the same as they would typically design it. Your typical uniform gravity loads plus your typical uniform wind load cases, and those cases could be 3, 4, 5, 6. So they would follow through apply the loads per ASC 7, follow their provisions, and complete their work that way. And design 2, where they apply concentrated point loads. In that case, they do not need to apply any uniform wind loads. The only thing they would apply their uniform gravity loads, which are dead and snow or dead and roof loads, and they would apply 2 cases of concentrated wind point loads without any additional uniform wind loads. That really simplifies things, because otherwise the designer would have to communicate which uniform wind loads were considered and resulted in knee brace reactions. Okay, so what information needs to be given to a truss designer? We reviewed that. What information should we be checking from the truss designer? We reviewed that. So the only thing I want to comment is knee brace forces on a truss are provided in the design tables. And let me show you what they look like. Right here. So this would be page 3 of 7.1 table. It could be table 7.1, 7.2, or 7.3, depending on the building size. But they're provided here as negative and positive horizontal and vertical values, and they're referenced as left brace, right brace, left brace, right brace. And the signage is defined. The positive and negative values are defined in the open statement here. How to interpret which one is what does it mean negative horizontal value? What does it mean negative or positive vertical value? So it's being defined here, and in case that missed, it's also defined right here, when we're talking about what information needs to be communicated to a truss designer. So I think that that addresses that first question. Any questions, Tim? Did you receive any questions that I should go over before I move on to the second question?
No questions related to that. There was a quick question. Can you provide an example of calculating X and Y knee brace forces as shown in the tables? And we have the calculation packages for all of these design packages at the NRCS state office in Pennsylvania. And if anybody needs that, then reach out to me, Tim Peters, and I can work with you to get a design package that you need.
Okay. Tim, can you remind me how much time I have left so I know how to manage my time?
Probably 10, 15 minutes or so.
Okay, yeah, let me go quicker. Okay, can you explain what knee, Y, and X braces are doing? What is the benefit of the X brace instead of a K brace? We have seen historically what happens to the structure if X bracing isn't installed. So let me show the figure here very quickly. So we have sidewall frames with Y braces, X braces, K braces. Did I miss it? Okay, so the question is specific knee brace. Okay, so as I said before, the default position was Y brace, really because it opens up the sidewalls very nicely, and then you could put whatever needs to be installed between the columns. It gives that flexibility. Any time that this design was not possible, meaning the columns were failing, and we did not want to introduce extra large column sizes that are not commonly available or readily available. So in those cases, we introduced X bracing, just like we show here. So like I said before, X brace is really K brace back to back. There is no additional benefit, except the reason we went with an X brace over a K brace is we found out that if we use K brace, your brace length really becomes 8 feet. It's half of an X brace. So which means once we applied lateral loads to the braced frame, and lateral loads come from the wind pushing parallel to on the building parallel to the ridge line. Once we apply those loads, we had uplift on the columns because of the overturning, and those uplifts, they were exceeding some of the capacities that you would expect with either typical shallow post foundation or with brackets. And keep in mind, sometimes those uplift forces, you use them in conjunction with some of the natural uplift forces based just on your typical uplift on the tributary area above the column. So because of limitations, to keep the design simple and prescriptions simple, we simply added 2 more K braces to each of the sidewalls, and they started to look like an X brace. So that's the background for that. The benefit of the purpose, of course, of the K or X or Y braces, number one, to provide lateral resistance to the lateral loads in direction parallel to a ridge line, but they also affect the axial design of each column. And that's part of the K value, which is buckling length coefficient, that we'll discuss in the next, I think it's the next question. So if you use a Y brace, your column buckling effective length would be higher than if you use an X brace, because with a Y brace is one of the sway frames. You have flexible frame here that can move left and right, and nothing restricts that movement. We don't have a functioning diaphragm, or I'm sorry, we don't have any shear walls that could restrict that movement. That movement is restricted exclusively through the bending strength and stiffness of the columns here. So the difference between the Y and X bracing is, anytime you use Y brace, your column size is going to go up, just because of those buckling tendencies of the column, buckling about the weak axis. Where here, anytime you use an X brace, that creates a rigid restraint at the top of the column, so that there is no deflection, no significant deflection or measurable deflection at the top of any of the columns. And so your buckling length coefficient is significantly lower, and buckling tendencies about the weak axis of each columns are also reduced. Can you explain why X braces? So I think we've done that. What is the benefit of X brace instead of a K brace? So we briefly talked about that it actually reduces the column size, or it actually makes the reasonable column size possible, where a Y brace may not result in a working design for some of the bigger structures. Of course, if the X bracing isn't installed, and of course you lose your lateral ability for the structure to resist lateral loads in a direction parallel to a ridge. You also reduce each column's ability to resist buckling tendencies. So that is a no. All right. Any questions on that, Tim, before I move on?
Not specifically on that, but another question did come up, or another question or two. Are the knee brace loadings shown in the tables related to the truss peak overhang configuration / orientation?
Okay, I'm sorry. Can you repeat that again? I was...
Yeah. Are the knee brace loadings shown in the tables related to the truss peak overhang configuration orientation? I think the question is saying, and Andy, correct me if I'm wrong, but does that overhang peak impact the knee brace?
Sure. Yeah, and I think the question actually probably relates to how the forces are being communicated, and then maybe I should have mentioned it, that we would say that those where's my the knee brace forces communicated to a truss designer, they should be considered in both directions. When we say left or right, it's not specific to the orientation of that overshot. In our sketch, we could have even removed the overshot just not to confuse the truss designer, because we don't want to communicate saying apply them. The direction is related or in reference to the overshot direction. It isn't. The truss should work with, for example, 1750 pounds applied to the left, but also the load should be reversed, 1750 applied to the right, and it should still work in this, or the truss should be rotated 180 degrees and the truss should still work. And I think that's the question. Is that?
Yeah, Andy, if that's not answering your question, jump in.
No, that does. I just wanted to make sure we wanted the trusses to be symmetrical, and also we didn't need to be concerned about you know, left and right during construction.
Very good.
Okay. All right. Very good.
And another question, Dimitri, and I think this is a question you have on your list, but the figure 5.7 and 5.8, is the end wall bracing required in all designs? Figure 5.7 and 5.8. This may be a new requirement for many contractors and engineers to understand the function and installation procedures.
Yes. Yeah, and that's actually the next question on my list as well. So figure.
This may be our last question to answer then too.
Okay. Oh, okay. We're that far.
But we're good. Okay.
Yeah, I really want to talk about K buckling length coefficient, but yeah, I guess we'll run out of time. Okay, so this, anytime we design a end wall column, the column needs to be strong enough, of course, to resist the applied loads, and that means axial loads, if there are any axial loads, but also flexural loads based on wind pressures being applied to the end wall. And in many cases, your column could be 20, 30, 40, maybe not quite 40, but approaching that length because of the, of course, near the peak, your truss is very tall in certain cases. And the column may not be analyzed where you stop it at the bottom chord. It would not be a correct way to analyze it because, number one, the permanent truss bracing was not intended to resist these loads, especially column concentrated point loads from end wall columns, and so we need to, if the column is strong enough to span the entire height all the way to the top of the top chord, and the analysis shows that the deflections under wind are satisfactory and the strength is satisfactory, and then the connection between the top of the column and the top and the roof diaphragm at the top is detailed correctly, then no, it wouldn't be required. But in my experience, that it's actually not the case. And the only way to argue that it is the case is when a designer stops the column at the bottom chord, assuming that somehow the bottom chord and permanent truss bracing within the plane of the bottom chord somehow are sufficient and provide lateral resistance to the column. That's really the only way that, in my experience, a designer can mathematically justify using the sizes that we typically have for the end wall columns. But once you actually model a full height column and understand that those bracing in the bottom chord are not sufficient, in most cases, when you look at BCSI, you see that they have 2 nails between the bracing. And then sometimes your load at the top of your horizontal load from the end wall column at the ceiling level could be 900 pounds, could be 1,000, 1,020, 1,300 pounds. Of course, that bracing, number one, is not sufficient strength-wise, and of course the connections are not sufficient. So for that reason, we use diagonal bracing, and that's really the primary reason of this diagonal bracing, is to provide lateral support to each of the columns. And we're taking the load at the ceiling level and we're pushing it, redirecting it to the rigid element, which in our case is the roof diaphragm. So that's the purpose of diagonal brace. We try to specify the nail so that it does work with all the designs. I will say that it's not always required, but again, because of the prescriptive nature, that's one of the compromises we have to make, that for simplicity purposes, we had to, you compromise with efficiency, unfortunately, in some cases. And then the same goes for, or similar concept does apply to this next figure, which does not have gable ends. The reason we apply it here is, number one, that gable truss is never designed to resist out of plane loads. So the gable truss on its own is not capable of resisting out-of-play loads, not the webs, not the cords. And so number one, here we introduced a vertical stiffener element. You can almost look at it as a mini stud wall that's being placed against the truss. And we say that the vertical element should be a 2x6 stud, 8 feet in center. And so that stiffens up the gable truss, but now we have to receive lateral loads from the gable truss, from the bottom of this vertical element, and we have to redirect it somewhere. And same goes again, the lateral bracing in the bottom cord, it's not, they're intended to be used as secondary bracing members, not primary load redirecting members, where this diagonal is a primary structural member. It's not secondary framing. It's intended to transfer lateral loads from one element to another. Does that answer the question, Tim, or should I?
Yeah, I think so, and I think we're about out of time, Dimitri. So I appreciate that. I really appreciate the work Dimitri put into this, and Tim Royer and his whole team on this design guide, and then your time today to Dimitri. So it's been a pleasure working with you, and we look forward to using this design guide more. I did want to say just a couple of things. I get this question a lot. This is a design guide, and I've been asked, is this required? Is Pennsylvania NRCS requiring this design guide be used? And the answer is no, it's not required to be used. This is a tool that we hope will be useful to you. We hope that at times it may expedite roof projects. We hope that at times it may improve our roof designs, but it's a tool for designers to use, and we expect that we are still going to be designers, and we're still going to make good decisions, wise decisions for roof designs based on your experience and your capability level. And as you have questions, bring them up. NRCS can answer general questions about the design guide, and I may need to go back to Dimitri at times. I hope he doesn't mind, and ask questions that might be more technical, but we will try to get you answers as best possible. And as I mentioned earlier, I do have Pennsylvania, the state office does have all of the calculations for all the design guides. It's thousands and thousands of pages collectively, but they are available at the PA state office. So reach out if you need that as well. So Dimitri, thank you. Heather, that concludes what I wanted to say here. And so we'll take it to the next agenda item.
Thanks, Tim. Thanks again, Dimitri. Very educational, very helpful. Hey, we are scheduled for a break. So you guys are sprung until 10:30. No, sorry, until 11:30, when we're going to start back up with John Ignash. So enjoy your couple minutes of freedom, and we'll talk to you soon. Thanks. Bye. So as people are coming back, it's not 11:30 yet, but I thought I'd try and maybe lighten things up a little bit as we're going through. Not that this is a heavy, depressing topic, certainly not at all, but for the time of year, I thought I'd share some holiday cheer maybe, and help you out with a couple jokes. So I should have probably started with some of this, but oh well. Hey, what do you call a kid who doesn't believe in Santa? Some of you guys have older children. Mine are still young and still believe, but what do you call a kid who doesn't believe in Santa? A rebel without a clause. Ha 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 ha. Yeah. I didn't say they were good jokes. Remember, guys, you get what you pay for. So, why did Frosty ask for a divorce? Never knew Frosty was married, but apparently so. Why did he ask for a divorce? His wife was a total flake. If
That's funny.
anyone's paying attention, you could at least give me a thumbs up or something, or a thumbs down. I'm good with a thumbs down, but at least knowing that someone's sort of, kind of listening.
Did these jokes come from Hosea Lasha?
No, but they probably should have. Can I do one more quick?
Yes,
Good.
please.
No one said no. Oh, I see the applause. Okay, thank you guys. What do you get when you cross a duck with Santa? A Christmas quacker. Just remember, guys, I have a smaller kids, so all my jokes right now, at least, are G-rated. At least I'm trying. But we'll have more. Trust me, we'll have more. Thanks, Sandy. Appreciate the comment. Hey, with that, is John on? John, are you loaded up?
Yeah, I'm here.
Okay. All right. Since it is 11:31, we are going to transition over to John Ignash from Virginia Tech.
Hey.
And John will be presenting on one of the CIG grants that he was the principal investigator for. But a little bit about John. He works as an extension specialist with Virginia Tech's Department of Biological Systems Engineering. His work tends to focus on the implementation of best management practices related to energy efficiency, renewable energy, and innovative nutrient management technologies. You guys noticing a theme today? Prior to his role at Virginia Tech, he worked for the University of California, Davis Air Quality Group on air quality monitoring of particulate matter for ag and natural resources projects. So John, we do appreciate having you, and we're looking to hear your project summary on reducing air emissions from on-farm poultry litter fueled energy systems. So with that, I'll turn it over to you.
Hey, great. Thank you very much. Let me share my screen here. And I like the jokes. I was taking some notes because I can't wait to tell my kids those later on today. So thank you for those.
Oh, trust me, they only get better or worse. I'm not sure.
All right, let's see. Hopefully I'm sharing a screen now.
It looks good. We can see it.
Got it. Okay, thank you. I apologize. We've kind of been more indoctrinated with Zoom than Teams, so I'm a little rusty on Teams. But thanks for the confirmation. Let me go to full screen mode here. Okay, thank you for the introduction. Like you said, my name is John Ignash. I'll give a brief kind of summary presentation on a conservation innovation grant project that we had titled Reducing Air Emissions from On-Farm Poultry Litter Fueled Energy Systems. So thank you for this opportunity to present today. Appreciate NRCS's support of this project through the CIG program. A brief outline, I'll go over the project overview, try to provide a little bit of context, and discuss a couple of farm sites in Pennsylvania with technology host farmers up in Snyder County and Lancaster County, working with on-farm bioenergy systems using poultry litter and other forms of biomass. But we'll talk about the beginning baseline emission assessments, project period emission assessments as things were improved upon, and then kind of a final snapshot of what the final project air emissions were. Then we'll highlight some of the outreach video material, some links for some additional information on the project reports, farmer interview videos, those kinds of things, and then highlight some areas for future work. Around 2015, there was a project that looked at on-farm poultry litter to energy systems. The project was titled Manure to Energy Initiative, led by Sustainable Chesapeake with a group of collaborators. And that project evaluated some of the challenges with on-farm poultry litter to energy systems, and there's quite a range of challenges. But one of the principal challenges that kind of rose to the top of the list had to do with particulate matter emissions from these distributed energy systems. So through this CIG project, we took a look specifically at total particulate matter emissions from on-farm poultry litter to energy units. So that was the goal of this project. The primary objective were to look at these two farms in Pennsylvania using poultry litter to energy units. And then the goal was working with technology providers, host farmers, to implement and assess abatement systems with the target of reducing particulate matter emissions by 70%. So that's a little bit of the context. As I mentioned, these were for two farms in Pennsylvania, one towards Lancaster, Ephrata area, the other towards Snyder County. Now, our project team had a wide group of collaborators. Just one person in a much larger team. I want to acknowledge the leadership from Sustainable Chesapeake, led by Kristen Hughes Evans, some of our investigators. The initial project concept was developed by Dr. Mike Booser, who's now with USDA ARS, and all the different source emission testing folks and labs and things we've worked with along the way. But on the left side of this slide, really important, want to acknowledge the collaboration with the technology providers, and then in particular, the host farmers. And this is host farmer Mr. Doug Klingler towards Snyder County, and Mr. Earl Ray Zimmerman towards Lancaster County. You know, without their openness, being able to collaborate with them, you know, they were operating the bioenergy units before this project, really teed up a great opportunity to kind of leverage their experience, the presence of these projects, and then look at, okay, what kind of abatement systems and improvements for particulate matter emissions might we be able to make, and then do our tests, and then also get the farmer feedback on how things work from their perspective. So really want to thank particularly those two individuals who made this all possible. What did we do? So from March 2019 through May of this year, our team completed 78 emission tests across 15 different abatement system configurations for two types of bioenergy systems. And the results are summarized in the following slides. And I'll go through these pretty fast, just in the interest of time. But please let me know your questions. But I'll kind of highlight here that the project information is available on a website, and I can drop that link into the chat for those that might be interested in looking at the reports or hearing the videos or seeing the videos and those kinds of things. Okay, location one. This is Snyder County with Mr. Klingler. He grows broilers on single flock litter, 500,000 BTU per hour hydronic heater. He had two of those units on the farm that share a common fuel feed, but were operated independently. Were installed by the farmer in about 2015. Here you can see some farm pictures and one of the screenshots from one of the interview videos with Mr. Klingler there. So, you know, things change, right? A local forest product manufacturer, Woodbode, was a source of a lot of his bedding material. They basically shut down for a period of time. My understanding is that they're back online, but at a lower capacity. That affected some of the bedding source material availability. During that time, Mr. Klingler and his integrator opted to go to a multi-flock bedding cycle instead of replacing bedding after each individual flock. And that is a different material to burn. So around that same period, propane prices had declined quite a bit. which was one of the drivers for him initially pursuing this project and looking at the project in 2014 and then implementing it in 2015. But between 2015 and kind of this year, propane was pretty low. So towards the end of 2019, because of challenges with securing sufficient biomass feedstock, and because of the value of propane, Mr. Klingler opted to idle the system in late 2019. But these markets are always in flux, and I think that he's gone back to single flock litter management, and then also propane. Sure enough, is definitely creeping back up. So he might be planning to put the system back in operation, which he indicates in his interview is, once these conditions change, he'll be firing it back up. So that's the status there with him. Regarding the emission testing, our first round of emission testing at that location was in March 2019. We with this unit, basically, we have the top picture is looking at the hydronic heater, and then the picture on the bottom where we're outside, that's the actual abatement device. Inside that shell is a wet scrubber device. So we were able to test it basically in two configurations, with and without the wet scrubber abatement. Our goal, keep in mind, was the 70% PM reduction. In this iteration, March 2019, we weren't able to hit that. We had some promising data outside of the project leading up to this that the vendor did at their facility, but we weren't able to replicate that information in the field. So with this configuration, only saw a 12% emission abatement with respect to mass emission rate of total particulate matter. So back to the drawing board a bit. We go to March 2020, a year later. This source test was conducted actually at the manufacturer's facility. We wanted to make sure we got things right before bringing anything else back out to the farm, Mr. Klingler's. And they did something similar, where it was 3 runs in the base configuration, and then 3 runs in the abatement 2, kind of supposed to be the new and improved system. But we still weren't able to hit that 70% number, an improvement from 12% to 37%, but still not getting the reductions we were looking for the project goal. So here we are earlier this year, and between March 2020 and February 2021, kind of over that summer and fall, the vendor, the technology provider, went back to the drawing board again with an iteration of the abatement system device and got it ready to go. And again, we're at the manufacturer's facility to test. And this time we said, well, if we're able to come test, let's also try testing the abatement device, but then also these fuel additives that we've read a little bit about in the literature, and also from experiences in Europe, where they'll use fuel additives for high ash fuels for a few different reasons. So I'll kind of get into that in the next few slides, but that brought us back there. We said, let's give this a shot, because we're interested in seeing if we can hit the project goal of 70%. So we did 3 runs again in the base configuration, and then 6 runs in the improved abatement configuration. So again, with and without the abatement device, we had more improvement, but still not hitting the 70% reductions. You can see opacity, which is visible emissions. These are the final values for kind of this project snapshot of the final emission test. You can see emission concentration, the top row, mass emission rate, pounds per hour, emission factor, pounds of total particulate matter per million BTUs, and then opacity, which is the visible emissions, kind of the plume that you see. And then some of those we got a little closer to our goal, but really across the board didn't hit everything we're trying to do. Some challenges also with this latest version of the abatement device, and this is the abatement device that you saw that was outside with the gentleman standing on top of it, a similar type of thing, but inside's a little bit different. But we had some back pressure across the abatement device, implications for consistent performance, and then the additional byproduct streams in terms of not just the bottom ash or fly ash, but also kind of a wet material from the wash cycles from the abatement scrubber. So we had some operational challenges, then also some management questions about what a farmer might consider some challenges with this particular abatement technology. So that's summary from that site 1. But I mentioned during that last round of testing there, we were able to do apply or try using some fuel additives. And this is there's a whole variety of fuel additives out there, and it's interesting to read a little bit about the different types and kind of mitigation strategies that different fuel additives might provide with kind of high chlorine and high alkali fuels like poultry litter, and not just poultry litter. So we have some experiences, or we've read about some experiences from other parts of the world using some of these fuel additives. So we figured, well, let's give this a shot because some of the PM mitigation or abatement looks like it could help. So we had a chance during this series of runs here to do a series of tests. We did 7 runs with different levels of a fuel additive. And really what's going on, a little bit of background here, is a lot of the particulate matter that we see, the fine particulate matter, the stuff that goes up the stack, is potassium species. So as soon as the potassium sees temperature, it's gone. It's looking for something to adhere to, or it in the heat exchange surface, or it's up and out the stack. So on the right here, to kind of give a little context, you're actually seeing that these are pictures of the filters that we use during the source emission tests. So you picture a chimney, a stack, or we cut a small port in the side of it, put a probe in. That probe sucks in some of the combustion gases that are laden with the particulate matter, pulls that across about a 3-inch filter, and then those gases go on through an impinger train. Well, what collects on those filters is filterable particulate matter. So you're looking at 6 pictures of the filters for some of these tests at this facility. The top left, A, is we did a few runs just with wood. And the wood actually burns fairly clean, but what you do see, the particulate you do see, is kind of a carbon soot type product. But then going from B to B, you see what it looks like when we're burning poultry litter. So that soot product is still there. It's just masked by the whiter potassium species. Looks kind of like baby powder almost in consistency, and it is very, very fine material, small particle size. Well, when we add this additive, what the additives do, and they work differently depending on what kind of additive we're talking about, but this particular additive, and generally speaking, they work to modify the ash bed reaction chemistry. So more of the potassium stays in the bottom ash. So it doesn't go up the stack or adhere to the heat, or not as much goes up the stack, or not as much looks to adhere to heat exchange surfaces or foul heat exchange surfaces. But more of it stays put in the bottom ash and is removed with the bottom ash cycles out of the combustion chamber. So we tried that with this particular additive, and we tried with from mixes from 0, basically just the regular base case, no additive, to 2%, 5%, and 10%. And we did see a reduction in the mass emission rate, total particulate matter, in terms of pounds per hour, from 2 to 5 to 10%, up to 61% reduction relative to the base case. Certainly more work is needed to understand this and what the opportunities implications might be for that, but it was interesting to see that we did see an effect. Back to the picture on the right, visually, you can kind of see that some of that effect where these things look different. So again, A is just wood, B is just poultry litter, and then C is C, where am I? Cyclone only. B is the wet scrubber, C is the wet scrubber, and then with the mineral additive starting at 2% for D, going to 5% for E, and then at 10% for F. So really, pictures D, E, and F are showing the effect, the visual change you see in that particulate matter going from 2, 5, and then 10% mix. So point here is A and F look more similar, and maybe there's some promising opportunities there. But more work's needed to really understand what that might entail. All right, site 2. This is the farm near Ephrata, PA, with Mr. Zimmerman. He grows broilers on single flock litter. He has about a 1.5 million BTU per hour boiler that was installed by Total Energy Solutions. It was a Pennsylvania design company in 2012. They're pictured in the top left picture are the folks from Total Energy in 2012 at the recently installed system there. There you see some pictures of Mr. Zimmerman in action, pictures of the ash material in storage, and then an overview shot of his farm. So Mr. Zimmerman's operation is unique in the sense that he grows some of his own bedding material using a miscanthus. So he harvests miscanthus, stores that material, uses it bedding. Part of his bedding kind of recipe, so to speak, where he uses a certain amount of miscanthus with wood shavings for a portion of the year before using all wood for other portions of the year. So that single flock material is removed from those 2 poultry houses, then used as a fuel source in his biomass boiler. The ash material is stored in these super sacks, but he's done some work with some other researchers at Virginia Tech looking at on-farm processing to granulate that material to make it more easily handled like a conventional fertilizer. And they've done work on the on-farm processing of that ash material, but then also the agronomic trials with that material. We have a video from a colleague on that too, if you're interested. So just some farm pictures here. We got the litter storage, the modified litter spreader used for a fuel hopper, a picture of the biomass burner, and then we have bottom left a picture of the bottom ash hopper that loads the super sacks. And then we have some pictures of the farm operation with his miscanthus, his harvester, and then Mr. Zimmerman working on the original cyclone that was installed with the unit, and then us doing some of the source emission testing, give you an idea of kind of what this place looks like. All right, so what do we do on the source testing side? Well, in February 2019, we went and did testing on the base configuration system. There was a lot of particulate matter emissions from the system. A lot of it lined the stack. So here's representation of kind of an estimate of what the effective stack diameter was, taking into account that lining of the inner wall there with the particulate matter material. So we had the kind of a baseline from 8 runs of what the base case emission rate was from the system that was installed in 2012. Plan was to go back January 2020. They're going to install the new abatement system with the new cyclones. And then we were going to let it run for about a flock cycle just to get the bugs out, make sure everything was properly commissioned, and then come up and do our stack testing mid-March 2020, which looking back maybe wasn't a good time period to pick. So that turned, we got a little delayed because of COVID travel things. Weren't able to get out there until November 2020. And unfortunately, the abatement system had been operating well, but periodically they replaced the bags in this new bag house there, and the new lot of bags to be installed did not fit correctly. So we went ahead, we're all mobilized while everybody's up there. So we went ahead and completed, our round of testing with 5 runs in the base configuration, and then 11 runs using the abatement system. I noticed quite an impact in terms of PM abatement for mass emission rate, reducing about 97%. However, given the situation with the bags, we all, wanted to kind of, okay, let's do this again with properly fitting bags, just to give it a fair snapshot. So we were able to go back April of this year and do 18 runs, same setup, only with properly fitting bags for the bag house, and similar results. So here I show some different types of emission units for the final summary: emission concentration, mass emission rate, emission factor, and opacity, again, visible emissions, and reductions across all of those, and exceeding our 70% goal. So in terms of that, the abatement system has been able to reduce particulate matter emissions by the project goal. But there's always challenges, right? It's not all roses. So Mr. Zimmerman indicates during the core of the heating season, he has to replace bags about every 2 months, kind of in between flocks, with about halfway point an extended air purge to cycle the PM off of the caked PM off of the filter media. Around week 6, he noticed some pressure changes across the bag house, often because indicating a bag tear or bag break around the 6th week. The abatement system itself imposes some gas flow restrictions affecting heat input rate. But the farmer, I think, I need to double check, but I think it's been since this biomass burner was installed, maybe as far back as 2013, 2012, somewhere in there. But for a long period of time, he hasn't used propane. It's been solely off of this biomass burner, and that continues to be the case. So it's meeting his heating needs, even with some of the restrictions imposed by this abatement device. Additional byproduct streams. So before the project, cyclone fly ash and bottom ash were commingled into one ash stream. Now he has kind of some more to deal with, where cyclone and baghouse ash are handled separately from the bottom ash. And those different ash streams also have some agronomic kind of implications in terms of potential use of materials and how you process it and things like that. Let me check how I'm doing on time here. So some of the extension videos that I mentioned, they're posted on this webpage, and I'll drop the URL into the chat. 3 videos. One I want to highlight, the far left one, is actually a project led by Penn State University with Dr. Chokas and Dr. Fatel. They led a project with NIFA, National Institute of Food and Ag, called Energy Answers for the Beginning Farmer and Rancher. And we were, a collaborator on that project with a much bigger project team that PSU or Penn State led. But the idea was to create energy-related videos for farmers, considering bioenergy, energy efficiency, these kinds of things. So we're able to work with some professional videographers through that project, with some interviews with Mr. Zimmerman, and then create that video. So it's titled, "What is it like to heat with on-farm bioenergy?" And then other videos that were made within the project are kind of operational maintenance experiences to hear firsthand from Mr. Zimmerman what it's like to actually run a litter burner. And he's been at it for about 9 years. And then the third column there, experiences selecting, installing, and managing an on-farm poultry littered energy system. These are Mr. Klingler's firsthand experiences in terms of those experiences and selecting, installing, and some of the drivers to motivating him to explore on-farm bioenergy and using poultry litter, and then what it was like, kind of good, bad, all of those types of things in his plans for going forward. So some rich experiences there that the farmers were kind enough to share with us and a broader audience, and captured in these videos. And links to this are available at the project website. Now, a video outside of the CIG project, but I think related to understanding potential of the overall system, is a video developed by a colleague, Dr. Mark Ryder, agronomist at Virginia Tech, doing work kind of from the ash stream on, looking at the ash processing, on-farm processing of the ash, and then also the agronomic properties of the ash material, and also versions that were producing biochar. Not the 2 projects I just talked about, but some projects earlier that were producing a biochar from a poultry litter material. Additional upcoming outreach, we're planning, or we've been accepted to present a presentation at the upcoming Waste to Worth conference in Ohio next year. Looking forward to that opportunity. But some next steps in future work. Now we have at least an example of one on-farm poultry litter energy unit, it's with a full abatement system, with improved particulate matter emissions. It's important now. We have a lot of the dots to connect these dots, or we have a lot of the information to kind of connect these dots now, but to develop a techno-economic assessment, financial model, evaluating the economic viability of these fully abated systems, including farmer and service provider time requirements, and have that information to help make informed comparisons, decisions, for other people that might be exploring these types of systems. They could use that information when they compare options related to other nutrient and energy management strategies, things like that. I think that's an important next step, is just to understand the financial feasibility of these fully abated systems. Along those lines, opportunities to optimize these abatement systems in terms of lowering capital expenses and operating expenses. Some abatement strategies, like a cyclone, or others like a baghouse, have different costs and time requirements. So some of those abatement systems work better when they're neglected, and other ones don't work at all if they're if they're not tended to on some regular interval. So it's to look at, might there be ways to optimize the abatement system a bit more? So maybe in cyclone enhancements that help extend bag life, or even some of the potential roles of an additive might play. Along those lines, evaluating the potential with fuel additives. How does system performance and longevity impact it, and what are the environmental and economic implications? We can show that we can improve emission performance, but is the project still viable from an economics perspective, and also from a farmer operational perspective? Is this something that would be worth the hassle and the time investment involved? Because these are not, these do require some hands-on operation, and I think the videos kind of help convey that message from the two farmers involved. Benchmarking of fuel properties. Poultry litter, it's not like propane. It's not at all like wood even. It's highly variable. Benchmarking may help inform what ranges of poultry litter fuel properties in terms of moisture content, ash, and other characteristics have, where they've performed well within thermal conversion processes, like in these two projects, but then also identify poultry litter sources or properties that might be problematic for a thermal conversion application. Because there's going to be certain ranges that just it's not a good fit, and other ranges where it might be more worthwhile, to explore. And then broader adoption. So with the techno-economic analysis, in hand, when we have the financial information, well, what are some farm and farmer factors that are important to consider to help inform broader adoption? Because these certainly aren't for everyone, and it's important to kind of understand that context. But there are locations where, if done correctly and evaluated properly and designed properly, it might be a good fit to at least enhance, some management options that for certain farmers to consider. So this is again the snapshot of the website that I mentioned that has some of the archived project materials. I'll drop that URL in the chat here momentarily. I encourage you, if you're interested in any of this, please take a look, and then also please feel free to contact me with any additional questions. Happy to answer any questions and share what we know based on this experience. Thank you again to NRCS for the opportunity to present today and the support during the course of this project. My contact information is there on the bottom right of the screen. Thank you.
John, thanks. Oh, sorry, Heather.
Nope, you're good. Go ahead, Tim.
I had a question, two questions actually. First question, could you maybe just dumb it down for me a little bit? And so how bad is the exhaust without having abatement devices attached? Can you speak to that at all?
Yeah, absolutely. Let me go back here. Maybe I can share my screen again. All right. Yeah, I'll it varies quite a bit. It can vary. I'll give you an example with this project here. I think you can see this is before the PM abatement. You get an idea of the visible emissions in that smoke plume up near that man lift there. And you might picture like I think of like the old Western movies with the locomotive coming around the bend, just kind of, black smoke coming out. So when you don't have, good combustion, you can have, high visible emissions. And that's true of a wide variety of fuel types. And certainly poultry litters, is part of that too. So with unabated, this had a cyclone, so partially abated, but the cyclone wasn't knocking out all of the finer particulate matter. But then I'll show maybe as a contrast, and we have some videos of the opacity, but I'm not able to play them right now in this PDF format. But let me see if I can go just to, if you picture that one example, and then this is during the project. So this is abated. So you can see we're actually, the gentleman standing by the tractor here is taking an opacity visible emission reading. The unit is on, up in the man left, conducting a source test, but you can see there's very little visible emissions compared to the previous photo. So good combustion is key. Abatement, proper abatement design is key. And without those things, you can definitely have some emissions that are of concern, both from just a visibility standpoint, but then also from a public health standpoint.
Thanks. And another question then, say a producer's looking to install a system, who should they go to talk about some of these things with, or to just learn about what considerations they should be thinking about? Seems like you've, with your research, started to identify certain things that work in certain situations, and just curious what support's out there for producers right now.
Yeah, that's a good question. I definitely would encourage anybody out there interested in these types of on-farm bioenergy systems to really reach out to your local extension office, USDA service center, network a little bit to learn about the different programs that are out there. Some range from cost share to technical assistance, things like that. But then also, once you start to kind of round out your knowledge a little bit about what is out there and where some informational sources might be, as you reach out to different technology providers, try to figure out where some examples are that you can go see, and then try to see them firsthand. It's challenging because of COVID and biosecurity on poultry farms and things like that, but really try to get to the point where you're able to kick the tires, where you can see firsthand and hear firsthand from an operator what it's like, good, bad, warts and all. Beyond just what you might hear in the sales brochure, because there definitely are some opportunities, but people really need to have kind of eyes wide open of what some of the challenges are. And I think reaching out, identifying people operating these systems, like the two farmers we were fortunate enough to work with, watch these videos. That would be another potential information source. But just to learn from the experiences, because there's experiences of these types of projects out there, and they certainly did not all work. And there's lessons to be learned in the on-farm poultry litter energy projects that did not work, just as much as there are to learn from the ones that are ongoing. So I would encourage people to kind of reach out and talk to people that are actually managing them.
Very good, thanks.
Thanks again, John. It's definitely much appreciated. It's a really good overview of some of the research that's going on, as well as some of the access or the tools that we can use to help our landowners. If you haven't and you're interested, I strongly encourage you to check out the videos that John was showing. If you have a producer that's potentially interested in something like that or something like this, those would be a good resource for them as well, at least to familiarize themselves with the different options and the systems that are out there, as well as those landowners' experiences. So with that, we are going to take a break for lunch, and we are going to start back up at 12:45. And we're going to talk about one of the dam rehab projects that are going on right now, and Mark Buckwalder will tell us some lessons learned with RCC. So enjoy your lunch, and we'll see you at 12:45. Thanks.
Thank you.
Hey, I lost the meeting there for the last session. I lost connection for the last session. Are we
Yeah.
getting started back at Q1? Is there any insight on air emissions from?
Probably the biggest thing is that it depends on what system you're using and it depends on your operator. John had a good website. See if I can re-put this in to the chat for you that gives information on what he did, but they also gives videos of farmer experiences. There's one farmer from Lancaster County and one from Snyder County. But it's kind of nice hearing in their own words the pros and cons. But that might be something you want to check out if you have time and energy and interest. But that's what some of my big takeaways from the presentation. Well, for those of you who are back early from lunch, I have a couple more jokes for you, since we have about a minute or two to go. What do you get when you cross a snowman and a vampire? Dun, dun, dun. Frostbite. I think that's my favorite one yet, or maybe this one. What's the absolute best Christmas present? A broken drum. You can't beat it. I think if you have small kids, that's awesome. What do you call an elf that can sing and dance? Elvis. Elvis, Elvis. Why don't crabs celebrate Christmas? They are shellfish. Steve, what do you get when you cross Santa with a detective? Santa Claus. That's good. That's really good. So here's one to kind of go with that. What do you call Santa when he takes a break? Santa Paws. Oh, here's another snowman one for you. What do snowmen eat for breakfast? Frosted Flakes or Ice Krispies? Hey, Mark, that's a good sign. You're loading up. Does that mean I'm getting the hook off the stage? You all set?
Yeah. Now I want to see if it works.
Okay.
Can
And we can hear you. We can. It's 12:46, and I've told enough bad jokes. So let's get back to our main subject of conversation. Thanks, everyone, for coming back. Hope you enjoyed your lunch. We are going to start back off the afternoon portion of today's engineering workshop with Mark Buckwalter talking about Beaver Creek Dam and the roller compacted concrete out there. Just so you have some background on Mark, he graduated from Penn State with a degree in Ag and Bioengineering in 2010, and he started with NRCS after graduation in Somerset, Pennsylvania as an ag engineer, and then later moved to the Lebanon office. Since then, he joined the state office engineering staff in October 2020 as a civil engineer, which included